Welcome, everybody. Thanks for coming to our Fabric workshop for the day. We're very lucky to have Dr. Paul Ruth from RENCI here. He's one of the PIs on the Fabric project funded by National Science Foundation. So we're excited for him to present and kind of introduce us to, what is the Fabric testbed? What can we do with it? How can we engage with it? And there's going to be a lot of hands-on training and things here. So with that, I will let Dr. Ruth.
Yeah, thank you. So, yeah, I'm Paul Ruth from RENCI. I introduced myself a little bit to the people here. There's a lot of people online, which is great. So I'm from RENCI at UNC-Chapel Hill. We have a research institute there called RENCI that our group has run many of these NSF testbeds over the years. I started, saying earlier, I started about 15 years ago at RENCI working on the Genie project, and we built the ExoGenie part of Genie. And then, after that, or during that even, I was one of the co-PIs of the Chameleon project. I did a lot of the networking part for Chameleon. And then more recently have been doing the Fabric, which is really exciting and a big part of everything we're doing. I'm gonna start off just to hopefully everyone can do this for me if you haven't already. But on this screen, there's a bit.ly link. If you haven't yet signed up for an account and you want to do the hands-on experiments, go to that link and follow the instructions. And I'll leave it up there for just a second so people can get it. What it's going to ask you to do is fill out a Google form. But before you fill out the Google form, you need to go to the Fabric portal, and there's a link on the form, and just log in with your institutional identity, so your University of Hawaii identity or whatever your IDP is. Create an account on Fabric, and then in the form, we just need you to fill out a little bit of information, but the main thing is to put your whatever email you signed up with, put that in there, and we're going to put you in a Fabric tutorial project so that you could actually access the system today and all the different resources we have. So hopefully everyone got that. If everyone doesn't have that, maybe we can add it to the chat or something here. But I'm going to go forward. Somebody raise their hand or complain to somebody if you're not in yet. Here's just another slide that basically says the same thing. Go to the portal, sign up for an account, fill out the form, and move on. Okay.
Oh, we got one question.
Yep.
One of our colleagues, Aaron, had some issues when trying to sign up for that. He got an error prompt. Aaron, I'm not sure if you want to describe your issue.
Hey, yeah, so the problem that I ran into is when I signed into my UH account, it brought me to that co-manage page, but it just says that you currently don't have any roles and it's waiting for an approval.
It's probably okay. You don't necessarily have any roles. If you've gotten that far, you're probably far. Let me. This is the hard part about trying to do this by myself right now. But what I'm gonna do is I'm gonna get Michael Steely on the line in Slack, and then I'm gonna have him check for all the university. Is yours a University of Hawaii account?
Yeah, it's University of Hawaii.
Yeah, cool. So I'm going to tell Michael Staley to approve all University of Hawaii things if you can. We'll get you set up. I have a guy named Michael Staley that's at RENCI right now on call to fix everything, but I'll have to run both things at the same time. But when we get to the tutorial stage, we'll get everyone set up.
Okay, thank you.
So for today, the agenda, I have just what is Fabric slides. So just a presentation we do, have kind of the long version. Feel free to stop me and ask questions if you want. If we're going too long, I can speed us up. And then that's about an hour maybe. After that, we have a tutorial we call Hello Fabric, which is basically getting your account set up and configured correctly and doing the most basic form of an experiment on Fabric. that could take less than an hour if things go well, but if they don't go well, then it could take forever. We'll get there and we'll figure it out. And then after that, we have another piece of the tutorial. It's usually part of the intro tutorial where we'll do some wide area networking. You'll see in a minute when I show you the map and all the resources we have, but you'll be able to create virtual machines on opposite sides of the planet if you want, and then do some wide area networking experiments. If we get there, we can run some iPerf and test some bandwidth and that kind of stuff. And with that, you have sort of the basic ideas of how to use Fabric. Then I guess we have lunch. I don't know how organized that's going to be. I think we're walking to the cafeteria or something. And then in the afternoon, we have another tutorial. In this case, Shauna thought it would be interesting to do some AI related things. And so we've been working with running Ollama inside of Fabric. So we now have that. You can run Ollama in Fabric. There's GPUs in Fabric, so you can do it on GPUs. Also interesting about this is it has a lot of, it's not just about Ollama. It's about how to deploy an interesting service in Fabric, how to access that service from outside of Fabric, how to access it from other places within Fabric. So it's kind of a long Jupyter Notebook tutorial, but when you get through it, you'll have to understand quite a few pieces about how to install services on Fabric. This one happens to be, kind of interesting given the current climate. And then the last hour, I thought I'm more interested in like what you guys want to do with Fabric and how we could help you. And so if you had any use cases, so this is kind of an assignment for the day while you're watching me talk and doing these tutorials, start thinking about like what it is you want to do with Fabric, and maybe prepare some discussion topics so we can spend the last hour talking about that, because we can help you accomplish those tasks. We can kind of push you in the right direction to say like, this is something you can do or can't do. During the presentations, you might actually get a bunch of ideas based on other users that are doing interesting things. So anyway, that's what we're going to do today. It's pretty flexible. If we get stuck somewhere, we can kind of adapt. It's not too strict a schedule here. So what is Fabric just generally? So Fabric's a mid-scale research infrastructure funded by the NSF. So they have large facilities, mid-scale facilities, and then sort of normal grants. So a mid-scale facility is between like $7 and $70 million. So Fabric is one of the first mid-scale RI2s. So that was when we first were funded. It was for $20 million grant to build all of this. What it is, it's a mid-scale research infrastructure, empowers researchers to securely like prototype and validate like really disruptive network designs in an environment that closely emulates kind of what you're doing today. So in the past, I worked on Genie. Genie was interesting, but it was kind of small, and you had virtual machines, and you're confined into the test bed. Fabric actually allows you to connect to external things and also scales in terms of performance. So we have like really high performance things. You can think of it as a scientific instrument or laboratory where you can deploy experiments, deploy prototypes. But you're doing it, you're experimenting with applications and protocols that run both across the internet, but also within the core of the internet. And that's what it opens up and lets you do. It was funded in 2019, like I said. We completed the construction phase. We had a 4-year grant for construction. That was a $20 million grant. We built it. In a minute, you'll see why it cost that much and took that long. Starting in 2023, we were officially open for business. So it's been about 2 years that we've been really open. Before that, we had a lot of beta testers and early adopters that were doing interesting things at the time. But we've been really pushing things in production the last couple of years. It's led by myself from RENCI. But we have collaborators from University of Illinois, University of Kentucky, ESNet, Binghamton, and places like that. I thought I put another slide in there. Oh yeah. This is the map. This is the footprint. So this is how big it is, and like kind of just to give you a sense of scale. So there's a worldwide footprint. There's about 35 sites. Each of these blue dots is a Fabric site. Of dedicated network capacity between the sites. So we own the layer 1 circuit between most of these links. The blue links are usually 100 gigabit per second dedicated layer 1 circuits that we control. The orange ring is 1.2 terabits per second ring. So it's pretty powerful. It looks like a real network, like the Internet 2 or something like that, except it's meant for you to like do really disruptive, crazy things and break it, right? That's the point, right? It's for you to do something that the Internet 2 would never let you do, right? So each location, each blue dot is a small cluster. It runs OpenStack under the covers. You never see that part, but that's what it does. Experimenters can deploy private routers and switches alongside traditional compute and storage, augmented with like interesting accelerators. So in the core of the network, we're putting FPGAs and GPUs and NVMe drives, and spinning disks and this kind of stuff. The idea is like, what would you do if you could, next to your switch in the core of the internet, have a GPU? Like, what does that allow you to do that you couldn't do today? So you can think of it as a research cloud, but also provides access to really low-level programmable networks and gives you just root access to all of it, right? But that's how it works. Other interesting things, so the orange spots here are external facilities that we connect to. These are actually the original external facilities. We call these facility ports from perspective of Fabric. So these are layer 2 circuits, or sometimes layer 1, that go to some external thing, right? You can see there's a Chameleon and Cloud Lab, which are other NSF test beds, other NSF mid-scale test beds. There's NCSA and PSC and San Diego Supercomputing Center and so forth. So these are supercomputing centers that are around. And you can connect your experiments inside of Fabric to the things that are in these external facilities. These orange ones are the original ones we put on the map, but we have 30-something of them now and growing. So at any given time, we have 5 or 10 that are in the process of being built. University of Hawaii obviously has a site. I think you probably maybe knew that, maybe you didn't know that. It's there. We don't have any orange stars there, but maybe we should have some, right? So like when you have your HPC center here, or you have a telescope on top of the volcano, whatever, these can be connected to Fabric. And then people can connect those instruments to anything else that's also connected to Fabric. That's the idea. And one more thing is that we also, through Internet 2, we can connect to, we peer with various other places, including public clouds. So if you have something in AWS or Google Cloud, you can actually directly connect to it via Fabric. And also Access, which is the big, HPC Center, HPC Federation. I don't know what they call themselves. So we peer with them. Yeah, so it's daunting to think about like how much work that is. And all of these places have contributed something. Like they're either letting us host a site, they're giving us network circuits or bandwidth, or they're another facility that's connected, or what have you. So they're all over the place. There's lots of them. University of Hawaii should be on here. So let's make that happen. So this is a little bit of the background about why we're doing this. So as I've already pointed out, like Fabric connects all these facilities that you already use. And allows people to connect them with these deeply programmable networks. But this is sort of an evolution of a problem. So like there's pressing new like distributed applications and research areas that demand like these really new types of research infrastructure for sharing and communicating data. So you can think of like AI as a big part of this. Like what is AI going to do to the core of the network? How are applications going to work when AI happens, or while it is happening? So you can think of the network as being transformed as connecting like individual applications to really supporting massively distributed applications that sort of flow throughout the edge of the core of the cloud, your pocket, your phone, or whatever it is. So these applications are moving everywhere. So these applications connect these scientific facilities, they connect large and small instruments, supercomputing centers, things at the edge, this kind of stuff. And like I said, of course, AI is distributed everywhere. On your phone in your pocket, and we have these new goals, which are not just how do we get as many GPUs as possible in a big data center, but it's how do we connect all the things that are all around the world with the GPUs, and maybe the GPUs even in your pocket. So these are all challenging things. We don't really have facilities to do a lot of the research on this, so we're building Fabric. Right? So these tools are great, but like I said, the internet or the network in between them is really just designed to store and forward packets. Like this hasn't changed for decades. Like the routers just store forward packets, that's it. So your applications are limited to running on the edge of the internet, and your protocols can only be optimized from the edge. So with this new emphasis on the edge core cloud paradigm, you want to run things both across, and also within the network. but you have these limited influence. So another way to think about this is like we have all these things that we've been working on for decades: instruments, data centers, public clouds, campuses. Spend a ton of money making them big and powerful, and people can use them, and people can configure them and done research. But we really haven't done much with the network, and that's what Fabric is for: is to like really open this up and let you experiment with what you want to put in the middle. It doesn't have to just store and fork packets. It can do compute and have accelerators. So yeah, Fabric, smart programmable cyber infrastructure. It allows us to run applications anywhere. So you can run them on the campus and the edge, the cloud, places where switches are typically found today. Enables in-network processing, so you can process things in the core of the network. Intelligent caching of data, distributed AI, a bunch of other things that haven't been invented yet, but I'm sure some of you will invent some and then teach us in the future. Fabric also scales both geographically. So we're kind of all around the world. You kind of saw that we had 3 sites in Europe. I guess I should have mentioned that. 1 in Japan and also Hawaii, and the rest of them are in the US somewhere. So it scales geographically, but also it scales into the performance. So we have these 1.2 terabit per second network links. Not that you would use a whole one yourself, but that means we can give each of you a 100 gigabit per second link, and probably you won't interfere with each other. So that's pretty powerful. 35 sites, like I say, mostly 100 gig plus dedicated layer 1 circuits, connecting to the real facilities that you already use, and all the clouds and supercomputing centers, stuff like that. It's not really meant to replace your existing infrastructure. It's really meant to be a powerful sandbox for you to experiment in a safe way where you can be really disruptive, really experimental. You can break anything you want, and we don't care. We kind of like it. Like the most interesting users we have break things all the time. So that's the point of it. Things that you wouldn't be allowed to do on the current internet, even if you had access to the internet too, or these kinds of things. It also is programmable. So what it lets you do is deploy a test version of your experiment, find out it doesn't work very well, and then you can very quickly just tear it down, rebuild it, redeploy it, test it again, and that's the point, is so you can programmatically just do experimentation with it. Yeah, it's smart and programmable, programmable core network. Yeah. Also, as a test bed, we have a bunch of features that are like for you to use to manage your experiments. We have a GPS-based clock synchronization across most of the system. So all of our sites have GPS devices. They don't move anywhere, so we're not trying to track where they are, but we can use that to synchronize clocks. And one interesting thing you can do with that is you can get like one-way latencies across a network. It's interesting when you look at that because you think that round trip time is the latency, divided in half. That's not how it works. One half is slower than the other almost always. Something interesting to find out. We have ways to measure power. We have optical layers. So we allow you to look into the optical layer of the network and see like what's happening with the light. We also have a bunch of tools for helping you package your experiment and share your experiment. And these are useful for like if you're writing a paper and it needs to have a reproducible artifact associated with it. We have ways where you can package those and make them available and cite them and things like that. There's something else I was supposed to say about that. Oh yeah, and primarily that uses Jupyter notebooks. If people are familiar with Jupyter notebooks, everyone? No? Yes? Yeah. So today you'll find out in the tutorials, we're primarily going to be using Jupyter notebooks and letting you run things. Makes it pretty easy because if you really wanted to, you could just hit play, and the stuff would work. But hopefully you engage with the different cells and play with them and do something interesting with it. Okay, so the impact on cyber infrastructure. So Fabric, the whole point is to enable you to do experiments that just are not possible otherwise. Like where you as a regular researcher somewhere don't have access to the core of the network. So we're trying to enable this experimentation. It's not possible otherwise. So what does this mean? So the next generation of cyber infrastructure will be unbound from compute resources. Applications will natively kind of flow through the network, including like smart in-network processing and computing. Yeah. And and there'll be new layers of software that we'll need for this, and hopefully you'll be part of inventing that. Beyond just doing experimentation, because a lot of people are thinking about this in terms of like researchers and grad students doing research projects, and that's all like what Fabric is supposed to support that. But a lot of, I think in this room, there's people that are running the IT systems and running the HPC centers and running these systems for the university. And in Hawaii specifically, you're running like network systems that are connecting like mainland to Guam to Japan and things like that. So you're doing a lot of interesting cyber infrastructure, like production things, right? So what you could do is you could use Fabric to create full-scale prototypes of systems you might want to deploy. And this is kind of interesting because we created a sandbox. You can kind of be a little bit loose with the security for a while until you figure out how it works. And if you do something that really breaks things, it doesn't really matter because it just breaks Fabric or it breaks your experiment. And a lot of times you've probably had an idea and you said, oh, wouldn't it be really cool if with Internet 2 let me do this, right? And of course they're going to say no, because they're going to say you have to like prove to me that that works before we're even going to justify the expense or the risk to do it. With Fabric, you can actually do the experiment and get some data that says, hey, this thing's going to work. Hey, Internet 2, hey, whomever, you should let me deploy this thing. I think it'll be really cool, right? Also, part of the full-scale prototypes, we actually, although our mission is to enable research, we have the ability to support production prototypes for some indeterminate amount of time. So if you have something that you want to deploy in production and it's kind of a risky, interesting thing, we can actually support it in a production style for a while. Once it gets popular enough, we'll have to work with someone else to like, hand you off. Because we are a research infrastructure and you'll have to deal with the fact that, other users are being disruptive and crashing things too. So you probably don't want that either, but we can support production things temporarily. Workforce development. So that's another piece of this that's really interesting, probably a lot for this group as well, is we have like one thing that's really interesting to me getting into this space and dealing with young like students that are playing with Fabric for the first time or playing with Genie for the first time, is that they have all these assumptions about what it would be like. What if I had a 100 gigabit network link across the country? Like, oh, I could just run this tool and get this really cool performance. It's like, no, you can't. It doesn't work that way. You have to tune the host, you have to tune the network, you have to do all these things that unless you had the experience trying this, you would never even know about, right? So one of the cool things about Fabric is it gives just regular people that are doing research, students, the ability to play with these like environments and tools that they would never have access to generally. Like I didn't learn any of this stuff in school. I learned it all by trying to build this. And we didn't know what we were doing, why we were building it. And now it's built, but now you can learn about it without having to be part of such a big project. So I think in terms of training the next generation of cyber infrastructure engineers, using these tools in the core of the network at these performances in just completely unrestricted ways is pretty interesting because you can learn a lot and have a lot of skills. And the fact that we have like these shareable tools, so you can like create a tool and share it with everyone else. That's also valuable. All right, where are we at time? Okay, a little bit on the design and architecture. So I don't know, like I think there's a mix of people here. So there's a lot of really low-level people that be hands-on, but also high-level people in this room. So I'm trying to have a little bit of both for everyone. I don't know if the people online are like that as well. So just reminder, this is what the map looks like. So lots of pieces all over the place. Each one of these sites, like I said, is a OpenStack cloud that has the ability to connect to the networks that both connect the different cloud sites, but also connect things outside of Fabric, right? So just remember that. We can come back to this map if we have some questions about it. So inside of each of those sites, here's the hardware. So it's basically a rack of just Dell compute nodes. They're pretty hefty though, so they're just 2 sockets with 32 cores each and 500 gigs of RAM in each one. So they're pretty big, but it's a multi-tenant system, so you're getting virtual machines on the system. But you'll see in a minute how it's a little bit like getting bare metal. So inside of each of these cloud sites, there's a number of worker nodes that are the OpenStack nodes, and they're just jam-packed full of PCI devices. In fact, the hardest thing we have is like making sure they have enough power to power all the FPGAs and GPUs and things, and then also just making sure physically the node has enough physical space to take a new card if we want to put it in there. But there's GPUs in there. Those are the types of GPUs. We were building this during COVID, so like supply chain dictated like how many of each type we could get. So we were just like, give us the ones that we want, but you know, they couldn't really do that. So we have a mix of different types of GPUs. There's NVMe drives everywhere. So there's, you can get 1 terabyte NVMe drives in most of the sites. There's a dozen of them or so in each site that you can have as part of your experiment. There's 250 terabytes of spinning storage on each site. So there's 250 terabytes times 30 something. There's a couple of special sites that don't have this spinning disk, but so we're talking a few petabytes of space, and we can give you persistent volumes on that. And also we have a really new thing down here, this persistent storage. I'll talk about in a second. It's pretty cool. There's network connections. So we have lots of ports. So it's, if you have one of these cards, it has a port on it. Most of the slow ports that you will get are 25 gigabit ports, but there's some that are up to 400 gigabits. So we have interesting network cards and programmable networks or programmable NICs and things like that. There's Tofino-based P4 switches. There's 4 of them. Actually, there's 5 because Rutgers basically gave us one. That's really theirs, but we could use it. There's, move this out of the way. There's reconfigurable network interface cards. So we have FPGAs that are these Xilinx U280 FPGAs. They have dual 100 gig ports on it. So it's an FPGA with 2 100 gig ports. You can do whatever you want with them. A lot of people run P4 on them. There's 2 or 3 different ways people are doing that. So you can have network cards with P4 in the card. We have Mellanox ConnectX 5 and ConnectX 6 cards with hardware offload. These are kind of traditional smart NICs. The ConnectX 5s are 25 gigabit cards, and the 6s are 100 gigabit. More recently, we've added NVIDIA Bluefield 3 NICs. If you're familiar with those are pretty cool. People are really excited about them. So these are network cards that have on them like a bunch of ARM processors and some accelerators. They can do cryptography, and what you can do is offload computation that you would have on your CPU to the NIC. And a lot of people use them for sort of cloud environments where you want to have the networking and encryption and things like that handled as efficiently as possible. So you can put that in the card. Those are very new, and lots of people are excited about them. And we have interfaces that are speeds 100 or 25 gig, 100 gig, and 400 gig network interfaces in various places that you could use. Lots of ways to do kernel bypass and hardware offload. So there's DPDK and eBPF and these kinds of things that will access the programmable NICs, the FPGAs, the GPUs, and all of it through PCI pass-through. And then the thing that we've added more recently with the persistent storage, we still do, but we had the ability to give you a volume on a site that you can then use, but it's sort of tied to that site, one of those blue dots on the map. And that's interesting, but people wanted it to be more flexible. So what we now have is a distributed storage system that you can get a volume on, and you can mount it from anywhere inside of Fabric. I'll talk a little bit more about it. I have a slide about it. But it's sort of based on Ceph, and you can mount the file system, or you can use it in a sort of S3 object mode and have these tied to either your user or to a project where you're sharing the storage with other users. All right. What do we have? External facilities. I mentioned these before. These are called facility ports. Layer 2 connections to something outside of Fabric. Last time I counted, there was 38 of them, but there's 5 or 10 that are being created at any given time. These, I think, are things that this group here should probably think about. There's probably things at Hawaii that you would like to connect to. We would like to help you do that. Some examples are these research infrastructures like Chameleon and Cloud Lab and Powder and Sphere and all of these. Different HPC centers, we connect to a lot of them. More are asking all the time. Different campuses, so like different professors that have some smaller research project in their lab. Sometimes we connect directly to them. Peering, so Via Florida International University, we can connect to things in South America. We have actually a lot of people from Brazil that use Fabric. So inside of the cluster, this is what it looks like. So I kind of mentioned it before, but this is kind of a graphical picture. We have this sort of sewing yarn fabric theme, like we call all of our things something to do with the yarn. So a hank is actually a measured unit of yarn, like if you're into knitting. So we call our sites hanks. So one hank is it's, like I said, a stack of Dell's, just Dell machines, packed full of PCI devices, and it's connected to a management switch. So this is a switch that you probably shouldn't be doing experiments on, but it's the way you will be able to SSH in to your experiments and access it and control it. So that's kind of a slower switch that you shouldn't really be using. And the devices that have network ports, they're all connected to this beefy Cisco NSO switch that's in the site. And so just all of them are connected there. We have the P4 switches. When they're there, they're connected into the NSO switch. And we have the spinning storage that is also connected into the NSO capable Cisco switch. And what you can do is you can deploy VMs that go onto these workers. You'll have a network interface out to the management planes that you can use to SSH in and control it. And then you'll be able to take all of these ports and kind of plug them into each other in various ways, whichever way you design it, and form a topology. And the really special sauce here is this switch is also connected to lots of other local resources. You could think of this as being like a supercomputing center or a telescope or something you have in your lab, and then also connected to the remote fabric sites over our dedicated connections. So, okay. Yeah, I'll try to stand right here. I'll point with my mouse, I guess. Okay, so the idea here is you can deploy VMs on those servers, and then you can get the PCI devices like embedded in your VMs, and then you can decide where the ports on those cards are connected to, and those could be somewhere else on this same site or anywhere else on any other site. And we'll talk a little bit about how that works in a minute. Anybody have any questions? I feel like I'm just rambling a little bit. I'm sure there'll be questions later. So kind of how does this work at a higher level? So you have this map, you deploy your VMs wherever you want. They have whatever PCI devices you want to have in your VMs in them. You can use the tools to create either layer 2 connections between your ports, or we have a layer 3 service we call FabNet if you want to make it really easy and just say, we don't care about doing the routing. We'll take care of the routing for you. You can just do the edge. And we'll mostly be using that today because it's a little bit easier to get started with. You can have different disks and NVMe drives. You can have GPUs, the FPGAs, connect to external resources via the facility ports, that kind of thing. So this is what you do. You can deploy this topology. You have root access on all of it. You can install whatever you want to install in here and run your experiment. That's kind of the way it works. At a little bit slightly higher level, it might look like this, where like you have a topology you built and you can connect to external facilities. Could be your institution, could be your collaborator's institution, could be one of these national funded facilities. Don't think that a lot of people see this and they hear me talk about this and they think that you have to connect to external things. Let's say the vast majority of experiments that happen on Fabric are totally within Fabric, and that's totally fine too. But the real, like one of the powers that we have is the ability to connect to the external stuff so that you can have a realistic prototype of your experiment. Okay, differentiators. Okay, so here's some of the things that we can do. We have the flexible range of network services. So like I mentioned, you can have layer 2 services. So you have 2 VMs on 2 sites. You can connect a layer 2 circuit between the 2 of them. And you own it. You can do whatever you want with it. We don't really control the layer 3 or above. So if you wanted to invent a new layer 3 protocol, go for it. And that's totally possible. We have a layer 3 service, which is we call FabNet, which is basically like the internet, but it only exists inside of Fabric. We have an IPv4 version of that, an IPv6 version of that. So if you want to play with IPv6 and learn about it, you can definitely do it through here. The facility ports, like I said, that are connections to external facilities. We have something called explicit route options. So this will actually let you, if you have a layer 2 circuit, you can actually choose the path through the network that it takes. So you can have multiple layer 2 connections between the same 2 VMs, and they can have different paths, and you can specify what those are, and you can load balance across them or choose what traffic goes one way and what goes the other way. All sorts of interesting things people are doing with that. With port mirroring, so inside your experiment, you can actually set up port mirrors to a third VM that can then take all that traffic and do some analysis of it, or like measure and monitor your experiment. And like I said, connections to the public cloud. So these are the different network services, the primary ones. There's probably some niche ones that I haven't mentioned here. In-network programmability. So I've mentioned this a few times to you. Inside the machines, you have GPUs, FPGAs, SmartNICs, NVMe drives, persistent volumes, Bluefield NICs, and all of this can be used to sort of, together or individually to program things in the core of the network. That's really, really powerful. Software-defined networking. There's a lot of people that are using P4 on top of Fabric. We have now 6 different ways you can do P4 with various levels of performance. The Bluefield NICs are the ones I'm most excited about. Those are brand new. Facility ports, actually I already showed you this slide, but this is where I usually talk about it. Measurement data. So we also have in Fabric, you can go, if you have an account on Fabric, we have some Grafana interfaces as well as some Prometheus APIs that you can query, and you can actually get information about any node or network link in Fabric, about what bandwidth's being used, how many CPUs are being used, all sorts of stuff. So if you want to sort of if you knew where your experiment was running, you could sort of watch your experiment via an external monitoring service. This is an interesting way to do it, to do your experiments. We also have a tool that measures latency. This was kind of a proof of concept to show that our GPU-based clock synchronization works. So you can go, right now, if you wanted to, you can go look and see what the one-way latencies are between various sites across FabNet. We also have some optical data that you can see. I don't really know that layer of the software, but if you want to know how the light is going through the fibers, you can get some information about that too. So these are just tools you can do to measure and monitor your experiment. Distributed persistent storage. So we have, this is very new, like I said. So we've leveraged Ceph to have private file systems per user if you want, or per project. We broke it up into regions, kind of like the big cloud providers do. We have, East, West, Europe, and then Asia. But because Asia needs to have, because every region needs at least 3 sites. Asia is Japan, Hawaii, and Seattle, because you need at least 3, so it's close enough. So you guys are in the Asia region. Thanks for being here. Otherwise, we'd have to include Los Angeles or something, but or probably just make it East. But anyway, so this is really cool because you can actually have a file system for yourself that you can pick which region it's in, or have multiple, and you can mount it from anywhere inside of Fabric and just have your data there. Oh, and also, if you have a project with a group, you can have one that's shared amongst the people in your project. Artifact Manager, this is the part that you can package the experiments and share them with each other. So there's a couple interesting things here. One, like I said, there's lots of conferences these days that want you to have a reproducible artifact along with your paper. If you make one of these, you can just cite it in your paper, and then other people that are reviewing your paper, they can just come get a Fabric account, download your artifact, and run it themselves. I mean, that's kind of the idea. You can learn from others. So we use the Artifact Manager to push out like tutorials and things. In fact, the one this afternoon, the Olama one, I made it as an artifact. So I'll show you how to download the artifact I created, and then you can run it and install it and all of that. So it's a good way to share things, tutorials like that. It's also a good way, like if you want to learn something about Fabric, if you go to the Artifact Manager and search for that term, there might be someone else that's already done something similar, and they have an artifact that you can just use. It's pretty powerful too. So it's kind of the go-to way to learn what everyone else is doing. So experimentation. So here's the next. I'm going to go some examples of some real experimenters that are doing real things on Fabric. Hopefully this gives you some ideas about what you could do here, or maybe people you want to collaborate with. So this is one of my favorite ones. So this is actually a project out of the Eastern Regional Network, which is part of it is at Rutgers. So at Rutgers, they have a cryo-EM microscope, and their cryo-EM microscope they can connect directly to it over Fabric. And what they do is that they have a packaged piece of software they call Cloudlet. And what this does is it takes images from the microscope and it processes them using GPUs. And so they can now deploy this anywhere in Fabric. And they usually use the site that's at Rutgers because it's very close to their microscope. And they can get GPUs and connect to the microscope and pull in images and then process them in the network. And then they ship the results off to Pittsburgh Supercomputing Center, where they get processed even more. And then from there, it gets shipped off to like a bunch of people that want to consume that output. So this is a really cool use of it. One of the other things they're doing that's really awesome is people at UC Santa Cruz, as well as the University of Wisconsin, also have cryo-EM microscopes and want to do the same thing. And so they're working on packaging this Fabric, Cloudlet is what they call it, and just sharing it with the other teams who can then just deploy them on whichever Fabric site is closest to them, and then they can just run it. So that's one of the use cases. This one I put in, it's a pretty new one, but since I'm in Hawaii, I thought I would talk about this one. So the NSF owns a bunch of boats. Some of them live here. You probably know about them. I didn't until about a year ago. So this one called Skoliak, last spring, it went from Honolulu to Alaska. And what they wanted to do is they wanted to know how well their internet connection works while they're on the boat, like out in the middle of the ocean. So what they did is we had, for the first go around, we just had a Docker container that they ran. They have a little data center in there. You can put a little Docker container in there. And we had it do a bunch of measurements of the performance, the latency, bandwidth, jitter, all sorts of things that they could get while they're under sail, right? Or does the ship go under sail, under motor? I don't know how it works. But so they did that, and they found some interesting things, like when the boat rocks a lot, it loses track of the satellites, and they switched to like their backup satellites and all sorts of stuff like this. They're now currently, we have an extension to this project where we've built like a dozen Raspberry Pis that are going to be put in a bunch of the NSF ships, and they're now going to use those Raspberry Pis to connect to various places on Fabric to test all their networks. So anyway, that's a local one that you might know about. Does anyone know about those boats? Yeah, okay, some of you must. I mean, they're from around here somewhere. Yeah. So another one, so this is CMBS4. So this is I thought an astronomy one would be good because you got a lot of astronomy going on here. So this is it's Chilean, it's a project they have where they have telescopes in Chile, and they're working on moving, this is the classic problem, is like everyone needs an instrument, it's producing a ton of data, it's got to go to the supercomputing center to get processed, and then it's got to be distributed to a bunch of people that want to consume the output. They have that same problem. You guys probably have the same problem too. So they actually use Fabric. They didn't actually connect all the way to the telescope, but what they were able to do is simulate the telescope in the Florida International rack that we have in Miami, and they were set up the other end of it at the NCSA where they work, and they were able to do like that half of their experiment. But the idea is as they can get closer and closer to having the telescope connected, they can do more and more experiments on Fabric. This might be something similar to what you would want to do here, but I don't know who works on that or what the goals are. But all right, high energy physics. So we have a site at CERN. The three sites that are in Europe, one's at CERN, one's at University of Amsterdam, one's at University of Bristol. There's a couple of different, the big projects, of course, are CMS and Atlas. They both have experiments that run on Fabric. In fact, CERN is probably our heavily used site. It could sometimes be difficult to get resources there, especially when Frank is running 400 gigabit per second data transfers from CERN to San Diego. And there's Rob Gardner from the University of Chicago is doing something called named data networking. which is a data transfer protocol that doesn't actually even use IP. So it's interesting that it can run natively on Fabric. So these are two of the bigger projects. There's another interesting one that is the drone related. So they have these drones that, so AirPaw is a drone related test bed that's at NC State in North Carolina. They connect to Fabric, and then through Fabric connect to Chameleon. They do experiments with controlling drones and cloud computing scenarios using Fabric as the intermediary. And then there's a climate one. So there's people in Brazil, a place called CP Tech, that work with Miami and Clemson, and they move data from Brazil through Fabric to AWS and process it all around, trying to like forecast El Niños and things like that. Again, I don't know a whole lot about it, but I know that we help them set the networks up, and they can do this in very experimental ways. A lot of education happens too. I wanted to bring this up. So Jorge Cachigno at UC's University of South Carolina, as well as he has Elliot Kofi, who is also there. They do a lot of work building low-level programmable, like tools for teaching low-level programmable networking. So they do a lot of things with P4, and they're actually part of the initiating our effort to have Bluefields. So they wanted to have that. So they have a really cool set of tools that you could go today if you wanted to learn how to program in P4 or use a Bluefield 3 NIC. You could go to Fabric right now, download their artifact, and they have a really well done set of tutorials and things on how to use these tools. And they use them both in their classrooms as well as they share them with lots of professors around. So if you had any sort of ideas, like something you wanted to build in Fabric, we could actually, you can emulate them, build your own tools, you can share it with everyone. Lots of professors can have access to it. This is a little bit of data about us, I guess. So like I pointed out, we've been sort of active for about 2 years. It took 4 years to build it. The last 2 years we've been in production. So there's like 69 known publications. Unfortunately, I think that number is very low because people don't tell us when they publish, and they sometimes don't cite us. And so it's hard. This is a big challenge in my world, is how do we figure out who wrote papers using Fabric? But just in the last year, in 2025, there's about 25 of them and growing. We find new ones every week, really. So we're over 2,500 accounts now. Any given month, there's a few hundred active users, more during the semester and less between semesters. About 60% of our users are education users, and about 40% are research users. That makes sense though, because a classroom comes in, they might have 100 students, so that kind of like inflates the numbers there. More than a couple hundred organizations, 171 different .edus. I think that's an interesting number. So there's 171 different universities that have somebody that has an account on Fabric. 34 of them are international. In terms of counts of projects, there's about 275 or so projects. 129 of them are still kind of active. Some of them are finished. And the interesting thing is most of those are research. So most of the projects are research projects, and most of the users are educational users. So here's a little chart. You can see when operations started, we kind of had an inflection point and started going up. So we have a bump every semester when new students arrive and are added. So we're over 2,500, and we'll keep going. This is another interesting one, I thought. So that these are the number of slices that people create every month. And it used to be pretty interesting because during the semester it would be really high, and between semesters it would be low. But now we have some users that have figured out how to do a lot of interesting things. So there's a couple of users that create like hundreds or thousands of slices like every day, just testing things. And there's other users that have one slice and they just keep it alive forever. So this isn't that good of a measure anymore, but it's interesting to see it. And there's been over 49,000 different slices submitted since we turned the thing on. So pretty proud of that. We'll get to 50,000 at some point. Join the community. I think you guys have basically done that. So once you create an account and start using it, you'll be there. I mentioned the ambassador program. So it's actually more than coming soon. I should update that slide. We have a couple of the ambassadors. So if people are interested in, if you participate with Fabric and you kind of get knowledgeable, we can consider adding you to an ambassador program. Upcoming events. So one of the interesting things is we go to different conferences. So we go to supercomputing all the time. So we have a site that Sienna purchased, and they actually ship it to different conferences. So been at supercomputing the last couple of years. It was at OFC the last couple of years too. So when you go to supercomputing, people going to supercomputing? Yeah, some people. If you go there, the Sienna booth will have a Fabric rack in it, and there'll be like a bunch of experimenters using that rack to do experiments at supercomputing. So it's a pretty cool thing. Yeah, so a lot about that. We also have monthly webinars. So if you want to learn more, every month there's a webinar. Some of them are like new features that we're going to talk about, and some of them are like we get users that are doing interesting things to talk about what they're doing. They're all on YouTube, so if you go find us on YouTube, you can watch the old ones. A lot of interesting stuff on there. And then this is for you guys. Right? So we have a knit workshop twice a year, every 6 months. So Sean was just at the one in Salt Lake City a few weeks ago. And the next one is going to be here, I think in this building maybe. So be prepared for that. Like half of what we want you guys to do today is to learn a little bit about Fabric, get a cool idea, build something interesting. We might, my hope is that there'll be a session where it'll just be some of you talking about what you've done, since starting today till then. So make plans for that. It should be fun. Hopefully there's people from, we have a hard time getting the Japanese teams to come to these because that's quite a trip. So hopefully they'll all come. We're probably going to make them come, and then hopefully there's a lot of interest from you all, and maybe more people that are in Japan or Hawaii that want to do this. Okay, so that's the end of this particular part of the presentation. It took about an hour. Good. Hopefully there's some questions. I did want to just remind you here. So for after lunch, start thinking about like what I talked about and things that other people have done, because the last session this afternoon, I think I just want to have a conversation, just a discussion. I have like almost nothing planned except a handful of questions. Hopefully we can get you talking, because I want to know what you want to do, and I want you to ask me if what you want to do is possible, and we can start thinking about it and hook you up with the right people to make it happen. So. Uh-huh. Oh yeah, for sure. Did I say? Yeah, so use cases. Yeah, add education. If you have education use cases, I'm going to do that. I'll add, because you just added that. We have where's my map? I'll show you the map again. I didn't mention this, but I usually do. I should have done it this time. There it is. Okay. We actually have. It's actually not on there. Interesting. I'll have to talk to them about that. So the sites that we have on there they all look somewhat the same. There's actually 3 different types of sites, but they're kind of different sizes. A little side note, too much information, I guess, is the dark blue sites are co-located with ESNet, which is the Department of Energy's Energy Sciences Net, and the light blue ones are we call them our edge nodes, and those are generally inside of supercomputing centers or at universities. We have inside the ESNet ones, we're really space and power constrained. So those are actually slightly smaller sites than the other ones. And I don't know if you know about Starlight in Chicago, but it's this big networking exchange point for research networks. So the Starlight one is much bigger than the rest of them. But also there's some special ones. So one of the special ones is at University of Kentucky. We have one that we call EduKY, so EDUKY. That's almost hard to say. But the whole point of that one is it's a much bigger site. So it has like, I don't know, 5 or 6 times as many nodes in it, but it doesn't have all of the GPUs and things like that. So it's like less expensive per node, but just more capacity. And so if you have a networking course where you're teaching things that don't need GPUs and FPGAs and that kind of stuff, we generally try to put you in that site, and you can set up experiments that are within it using the same APIs and protocols that we have to use the whole system. And then, so if your students then get more experience and want to do interesting things, they can kind of spread out. But for now, we can kind of keep all the education people in one place, but there's a lot of power there. So know that we do actually support education stuff pretty explicitly. All right. Do you have any other questions? The next thing. Yeah, we could take a short break. Then the next thing is to do the, see if I can, this is going to be trickier. So I'm going to have to, yeah, I'm probably going to switch to just showing my desktop so that I can switch between terminal windows and things like that. But the next thing is just to get everyone running the Hello Fabric tutorial, which being I'm the only one here and I'm going to have to communicate with Michael Steely through Slack, might be a little challenging, but we can get most of you going, and then the people that have some account problems, we can get you going after that. Do we want to take a break then for like 10-minute break and everyone get coffee or whatever? All right, so we'll be back at 10 after, I guess. hopefully everybody has filled out that form. And I just checked them a second ago, there was 20 something people that have signed up. If your name's in yellow here, I added you to the project yesterday. So you probably are already in, and Michael Steele, who's at RENCI, is now in the process of fixing the rest of them. So hopefully they're all there. When we get to the stage where you can look and see if you're in a project, hopefully everyone says yes, but I suspect there'll be at least 1 or 2 outliers there. For now, I'm gonna run this like this, where I have just my slides up here, so I can switch back and forth between some different tabs and some terminals and things like that. All right, so it looks like most people have signed up, so that's good. So this tutorial, hopefully, it is one of the tutorials that is either going to go really fast, or there's going to be all sorts of account issues and corner cases. So hopefully what we can do is get most people that get it working, get you set up to just kind of like play with it. Like you can get it up to working, and then you can just kind of start interacting in a sort of a free form way while we help everyone else get set up. So anyways, we call this tutorial Hello Fabric for obvious reasons. This is just a way to basically make sure your account works, with the account all configured correctly, and show you how to use the tools to to configure your first really simple experiment. All right. So I have in here the map and other things if you want to use it as reference. But the most interesting part here are these are things to know when using Fabric for the first time. So these are things that just kind of a list of things that we generally tell people, because if you don't know these things, you probably won't assume they're true. First is, and I think most of you have figured this out, is that the user accounts, they all use CI logon. What this means is we have, University of Hawaii has an identity provider. We don't actually have accounts for you. We just ask University of Hawaii, is this person who they say they are? Same is true with all the other users. We prefer that you use your institutional identity provider. Most of you seem to be able to do that. Other IDPs are possible. There are universities out there that don't have in common and can't use the CI login identity provider from their university. Because of that, we allow Google and Microsoft accounts and a few other things. Don't use those if you can use your institutional one. Also, if you do know anyone that has to use Google or Microsoft, there's a different process, because we don't want every Google user to be able to sign up for an account. So there's a manual approval process for these ones. But if your institutional IDP works, then you can just get in. You don't even have to ask us for an account. Enrollment, you sign up via the portal, you click the sign up link, follow the workflow. Make sure you confirm the email. That's like one of the big things. People don't read the instructions, and it says like, go to your email and confirm your email. If you don't do that, it's not going to work. And the one last one that probably people in here have done is that there's a quirk in that once your account gets approved, we can't add you to the project until you've logged into the portal at least once. So if you haven't yet gone to the portal and logged back in with your account after getting your account created, go do that right now. And then we'll be able to add you to the project. Michael Steele is in the background doing this for me right now. And that both those rules are important to know if you're going to like teach a class and you're going to sign up a bunch of students or something. It's a quirk. You can't find them to add them to your project unless they have logged in at least once. Projects. Okay, so I said project. What does that even mean? So projects are just a group of people collaborating with experiments. People use projects a little bit different. Sometimes it's a professor has a bunch of students, so they have one project for all their students. Some professors have a different project for each student because they're kind of working on different things. Usually a class will probably have one project for the whole class. So it's a group of people collaborating experimenters. The important things are it has shared permissions. So every project has permissions to use certain things. By default, the project has very little permissions. So if you want to use GPUs, by default, your project doesn't have GPU access. You have to ask for those permissions. You have to be in a project to access anything, to access the resources. For today, we have a project we call Fabric Tutorials. This is a tutorial, so we're going to add you all to that project, and you'll be able to use the system. Going forward, many of you will want to be project leads. And what this means is you can have your own project. And you can just request us to create a project for you. You will own the project. You'll have to tell us what you're going to do, what your kind of area of study and that kind of thing is. We just want to know, like, we have requirements to the NSF to tell them what people are doing, and they're not going to give us more money to keep running this unless we tell them you guys are doing great things. So this is a mechanism for us to know what great things you're doing. Project leads, they have to be like a professor or some sort of senior researcher. More or less, it can't be a student. That's really the main requirement. So if you have a graduate student, they can't, not even a graduate student cannot be a project lead. You have to have a professor that's project lead, and the graduate student can be a member. The key for that is like the project lead is responsible for the project and the membership. So since anyone with an in-common identity can create an account, and any project lead can add any account to their project, basically we don't control who's in the projects. The project leads do. And we need someone that's responsible so that if somebody starts doing something malicious or accidentally bad, we can go to a professor or someone responsible and say, hey, your project member is doing this bad thing. Help us fix it, right? Permissions, like I said, projects only have a very limited number of permissions at first. You'll get errors in the APIs that say you don't have permission to use a GPU or an FPGA or whatever. If you see that and you think you want to use a GPU and you have a good reason to it, if you just request the permission, we'll look at that and we'll add it. If you say you want to mine Bitcoin, we'll say no. But if you say you're going to do some interesting research, we'll say yes. Mostly we just want to keep it so that the scarce resources are available to more people. Using Fabric, so by using, I mean deploying experiments. There's a few different ways to do it via the portal, and I'll show you the portal in a minute. I'll give you a tour of all of these things in a minute. You can create really simple slices, and you can view slices. You can delete your slices. You can't really do really complicated things in the portal interface, but it's a good way to. It's really good for viewing your slices, but not a whole lot else. The lowest level, we have a REST API. We don't really recommend you use it. Primarily because it's a really simple API that basically takes a complicated model that is the description of the topology you want to deploy, and it ships it through the API, and then we interpret it and create it. The complicated part is creating the model, not using the API. And unless you're really experienced, you're not going to be able to write these models by hand or anything like that. You need a tool to do it. So we have this library, it's a Python library. We call it FabLib. The main thing it does is it helps you construct these models, saves them, interpret them, modify them, read them, all of this kind of stuff. And it also can submit the request to the REST API. It also does some interesting things. So it has some tools that sit on top of your experiment that are not really part of like creating the experiment, but it has tools for SSHing into your experiment. And you'll see why that's important in a minute. And controlling some configuration of your experiment. So we'll show you all that in a minute too. So this is the library. It's in, you can pip install it. It's just a Python library you can use. The most recommended way to use it is using our Jupyter Hub. So we have a Jupyter Hub that runs in Google Cloud. All of you, once you're added to a project, will have the ability to create an environment in our Jupyter Hub. The good thing about that is we've hooked it all up with CI logon. So when you log into the Jupyter Hub, it creates a token, installs it in the right place. It has all the libraries and tools installed. It even comes included with a bunch of example Jupyter notebooks that you can just run. And in fact, this Hello Fabric one is one of those, and you'll find it here in a minute. So highly recommend to use that. When you start doing some really advanced custom thing, you might want to move to just using FabLib installed on some server that you run yourself. It's really just Python. It's not that hard. We actually have pretty good luck just running that inside of VS Code virtual environments. That's primarily how we use it ourselves. Getting help. So there's the portal, like I say. On the portal, there's all sorts of things you can see about your slices and your projects and your groups and managing all that. There's also a way on the portal to create tickets. We don't really want you to create these tickets if you don't have to, because there's better ways to do it. So we kind of try to limit the portal tickets to things that you don't want to really kind of say publicly or really are more about you specifically. So if you have a problem with your account, there's a way to create a ticket and say, hey, my account's screwed up. How do I fix it? If you need to create a project and you need to tell us about your project, if you want to request permissions, these are the kinds of things that the portal tickets are for. We have a knowledge base, which is just a WordPress site that has a whole bunch of documentation on it. That's the primary way to get the documentation. Lots of articles. We also have blogs there. We also have announcements for different events and things like that. We also have a forum or a set of forums. This is a place where you can ask questions in sort of a more public way amongst everyone that's using Fabric. Hopefully you can even answer questions for someone else that asked them. We actually have had some really cool experiences with that where when we first started out, we didn't really know how to use DPDK to do anything, but some of our users figured it out. And then some people asked some questions and we didn't know the answer to, but our users were actually more helpful than we are. So hopefully if you want to learn something, go to the forum. Maybe someone's already asked that question. Maybe you know an answer to something that no one else knows about. Then we also have the documentation about the FabLib library. It's maybe one of the more useful things. If you go to read the docs thing, that's created automatically from our code, and it just has the whole API and all its gory detail, and I'll show you about that. I'll come back to this and I'll go to each of those links and kind of show you a tour of it all in a minute. Accessing experiments. So this is an important thing that can be tricky for first-time users. So I've worked on a bunch of these test beds over the years, and they all get hacked all the time. So like the number of times we find people mining Bitcoins on whichever cloud platform I've been working on is like, it's on a monthly basis, right? So when we built Fabric, we were actually more mindful of some of the security. We really want to keep all of that out so that we can have this secure sandbox for you to be really disruptive and not be impacted. So because of that, one of the main things we have is a Bastion host. So you can't actually access your VMs directly from the internet. You have to jump through the Bastion host. And this has gotten rid of like nearly all of our problems we've had with these test beds getting hacked. This is really great because now you have this really protected sandbox, but it's harder because you now have to figure out how to jump through the Bastion host. It also, we don't really allow you to have services that you expose to the public internet. Although I'm going to show you, especially this afternoon with the Olama a way where you can expose services to yourself or to other groups of people that you work with, but not the public internet at large. Right? So when you SSH, there's two sets of keys you have to know about. There's like the Bastion keys. So you have a public-private key for your Bastion host. We have some tools that automatically install it in our Bastion host. You can manage that through the portal, or like we added it to the FabLib library, so the FabLib library will do it for you. That's usually the easiest way because you don't even have to think about it. It just does it for you. Bastion keys expire every 6 months. Every once in a while, we get someone saying, hey, why doesn't my account work anymore? It's like, your key expired. I mean, that's often the answer. Slice and sliver keys. So we call an experiment that's been deployed, we call it a slice. And the resources in there are called slivers. So there's a different key that you're going to put into your VMs to access it. So when you jump through the Bastion host, you'll have two sets of keys, one for the Bastion host and one for the VM that you're eventually going to land on. That can be confusing to some people. The keys are pushed automatically to the VMs. Also, we have a cool feature that probably won't get too deep into today, but if you have a group project and you can all go to our portal and you can register public keys with your project, and then anyone in the project can deploy a slice that has all of your public keys in it, so your whole group can access your whole experiment. And there's some automated tools to do that. FabLib has a bunch of cool features in it that'll execute commands on the VMs for you. You can just do that with a Python call, just execute, and we'll do that today. And that actually just jumps through the Bastion host using SSH and all your keys. And it's all transparent to you, so you shouldn't have to know anything about it. Hopefully it makes it easy for people to get started. It also has some tools for transferring files in and out of the VMs. And it just generally automates the use of SSH. Hopefully it's very useful for especially students in a beginner class. Management network and data plane network. So this is one of the key things. So when you create VMs on Fabric, like I pointed out, there's a management network. Maybe I can point with this. So this is kind of a general way that this would look. You have two hosts. you have, the public internet, you have some VMs that you deploy across those two hosts, and you have a data plane that connects them, but they're also connected to the internet via the management plane. This is what I'm talking about with the Bastion host. So in order to get to the management network, you're gonna have to jump through our Bastion host. And that's the trick. And we have a bunch of tools that help you do that. Another thing that's worth noting here, I just remembered it in my notes here, is that our management networks, many of them are IPv6 only, and some of them are IPv4 only, but most of them are IPv6. This is mostly a result of the fact that the ESNet, so the U.S. Department of Energy's networks that we're on, they are IPv6 only by mandate. So we don't have a choice on their sites. So because of that, we kind of try to make it a little bit more consistent across all the sites. Turns out you guys don't really need to care about that, because the other benefit of making you jump through the Bastion host is only our Bastion host has to know about IPv6, not your machine, not your laptop. So this actually solves a couple different problems as well. Yeah, and then so the idea here, I think there's more pictures. Yeah, so the idea is like an attacker can't get into either of those, but you can bounce through it. And then, there you go, oops, let's go back. All right, and then the data plane is where you do your experiment. So one of the main things to try to do is not use the management plane to do experiments. It's mostly used for SSH access, as well as if you want to do like a yum install or configuration, that kind of thing, do it through the management network. And then the experiments can be done here. And the data plane, you have free reign to do whatever you want, right? You can be as disruptive and crazy as you want. If you start doing stuff on the management plane, the different campuses that are hosting our sites are probably going to tell us about that. In fact, that's most of the problem we have, are people consuming like massive amounts of bandwidth out the management plane. Usually it's because they don't know what they don't know. Yeah. But yeah, so use your data plane, use it however you want, be disruptive, break things. If you break something in a cool way, let us know, because we want to know. Okay, so now that's sort of like the main pieces. So now you know Bastion host, you know keys, you know how to get some of your tools. So here, let me go back real quick here, and I'm going to start with the hands-on tutorial and take you through some of these different pieces here, like this portal, for example. So you can follow along if you want at this point. If you go here to the portal, the address is portal.fabric-testbed.net. The first time you log in, you'll have to accept the cookies. I don't know why I'm accepting cookies, but and then when you log in, the first time when you log in, you should hit the sign up. Hopefully everyone's done that. We hit login, and you're going to be taken to the University of Hawaii page here in a minute. Don't choose Orchid. That's very bad for weird reasons. Conveniently, if you just type Chapel, you get University of North Carolina Chapel Hill is the only one. So that's not that matters to you. But if you, now that I log in, oh, I forget, I have to use this. It really did log. Oh, I rebooted earlier. That's what it is. Use my YubiKey and all that. Okay. So now we landed on the main Fabric portal page. You can see here at the top, there's some tabs. We'll go through many of them, maybe not all of them. I'll scroll down just a bit here. You can see some stats about us. This was 2,500 like yesterday. So I think that's mostly you guys signing up for accounts, got us to 25. If you're interested in reading about things that other people are doing, there's Fabric publications. We have this tool here. You can just look at all the publications we know about. You can look them up, cite them, read about things. We have quite a few of them these days and growing. If you do write a paper, let us know. It's very important. If you want us to stay funded, then you must do that. All right. Where am I going here? Some stats about the projects. Let me get this out of the way. Well, I'll come back to that, I guess, in a minute. So the one thing you might want to do is you go over here to your corner, and this is your account. You click on your user profile, you can see some information about you yourself. Maybe the more important thing here is, your Fabric ID or your Bastion host login, or a few other things like this might be important for different things you're working on. You can also see your SSH keys. You can see project roles. So you can see, hopefully, if everyone goes to your project role, you'll see you'll be able to see that at all. But if you see that Jupyter Hub is checked and active user is checked, then I think that probably means you're in a project. We can check that again. You won't have quite as long a list as project roles as me, because I am, for historic reasons, the owner of a lot of projects. I don't actually own most of them. I just, on paper, do. You can also go here and see all the slices that you have up. I should have at least one up. If I have more than that, I might have to, yeah. So I have a pre-baked version of the Olama slice in case it didn't come up. I just wanted to have one ready to go so I can show you. And I have my slice for me playing with it earlier that I'll have to delete before I can do my Hello Fabric experiment. If you click on any of these, you'll be able to see a kind of a GUI. This is a very simple one. This one happens to be at New York. It's called Node 1. If you click on here, you can get information about it on the side. I actually don't have a more interesting slice to show you. I should have made a more interesting one. But if you have different networks and things, they connect to each other in a very graphy way. Yeah, and interesting things to do on this page is like you can view your slices. Maybe the next most interesting thing is being able to delete them, because it's a pretty easy way to see them. Actually, I'm going to delete this one right here because I can. Yeah, I forgot about that. Okay, so my slice is now deleted. It's not actually there, my slice list. Yeah, so I have my pre-baked one ready to go, and it's there. Okay. Tokens, if you're going to use the FabLib API outside of the Jupyter Hub, this is where you can go, and the credential manager, you can download a token and install it in your whatever machine you're using. SSH keys, like I said, artifact manager. So this is where you can go to create artifacts. You can see I created this one for you. That got the Olama example in it, and in a little bit we'll show you how to get to that. But I also have a bunch of other ones for all sorts of other reasons that I'm involved with. Okay, so that's yourself. If you go to experiments, this is where you should all see something. So if you go to projects and slices, if you have selected there My Projects, hopefully you see a project that's called Fabric Tutorial. This Fabric Tutorials slice here. Does everyone see this slice? Did anyone not see it? I'm guaranteed there's somebody that doesn't see it, because in order to see this Fabric Tutorials project in your list of experiments, or if you go to experiments, projects and slices, unfortunately, I'm in a million projects, so I can't really filter this out. But if I search for Fabric Tutorials, if you see this in your list here under My Projects, that means you're good to go. And if you don't, then that means we're going to have to fix your account somehow. So tell me now. All right, maybe we're doing very well. This is, I think, okay, quite good. Michael Staley's working his magic in the background, it looks like. Okay, other things we can do. If you go over here to this resources overview, this is actually a live view of the resources in Fabric and like what's being utilized, what's used and allocated, and what's available. Usually don't go this far over here, but here you can go over to Hawaii and we can see the Hawaii site and what's used and not, and what kind of resources you have there. So this is useful if you're trying to find a site that is has a certain type of resource, or if you want to make sure they're available. I'm really excited that you're all in that project and it worked. I'm very scared that that's not true. We'll see. It never goes that cleanly. All right. And another one, if you go up to this resources tab, there's this measuring and monitoring tools. This is a cool one too. So you can go and this is some Grafana, and you can go here and open the tool. You can log in. You can click on any of these, and you can get like bandwidth across that is being used on Fabric, or CPU utilization, or so forth. And you can log into this with your Fabric identity and see it. I think you can even create your own graphs if you want. So that's something if you're interested in how, like, what's links are up or down, or how much bandwidth is being used, that kind of thing. You can go there. I want to open that. Oh, I guess down here is where you can see your optical data and then your one-way latency monitor that we have in here. So if you're interested in these other tools, I don't know why this popped up. Okay. Next, I'm going to go here. If you go to the knowledge base, if you click on knowledge base, this takes you to our WordPress site, which has a bunch of just articles and blogs and these kinds of things on it. So you can see down here we have events, news, and blogs. You can kind of check those out. And once you sign up for the mailing list, you'll be sent most of those every month or something. If you're interested in teaching on Fabric, there's a whole section just on that. We have a special way of creating projects for that. And we have a bunch of other tools and things that people have contributed to the community. So you can, if you're looking for just basic, networking 101 kind of laboratory assignments and stuff like that, there's a whole bunch of them already available for you. So if you're interested, go check it out. Technical guides, I'll show that in a minute. Getting started. This is where you might want to hang out for a little bit, is get into the getting started ones. There's a bunch of articles about how to do various things, most of which I either already said or will say shortly. But if you get stuck or if you want to teach someone else how to do this, there's a getting started, whole section of getting started there. The technical guide has different things like the FabLab API. It has how to use the Jupyter Hub. There's a bunch of interesting tools that people have added. So there's some different kinds of tools that people are using for various reasons that some of them our users have contributed them. There are measurement frameworks. So this is a framework that allows you to measure your experiments, how to use Jupyter Hub portal. So in the FabLab API, there's an interesting, very useful one. If you go FabLab API and then FabLab API again for some reason, you see here this FabLab API documentation hosted at readthedocs.io. Make this not in dark mode for you. So this is the FabLab API. You can see it shows you how to install it. You get down here and there's different slices and nodes and components. If you go to these nodes and so forth, you can see just all the classes and methods and gory detailed description of it all. So when you're using your Python library, this is the place to go figure out how to use it. I wanted to leave that open, but all right, okay, I'll go back. Also on the knowledge base, we have this button over here that says go to forums. This is very useful. You can log into the forum. You have to log in to be able to post, but you can view it just by being here. But we have on here a Fabric general questions and discussions. This is where a lot of the questions are asked. You can see that Kamal answered a question 5 minutes ago, so it's pretty active. These are just usually people having problems with something, and they're asking a question. We have a group of students at Clemson University that are required to watch this and answer questions on our behalf. But also, like, Kamal is one of our senior developers, and she answers a lot of the hard questions. So that one's about FPGAs and GPUs, so probably that was a hard one. So lots of users answer questions, people answer questions. If you have a question, ask it here. You could also, there's a search bar up here. If you want to see if somebody has already asked that question, you can search and get it. This is the go-to place. Like, if you have a question, go here, ask the question here. And if it can't be answered by the Clemson students, part of their responsibility is to find the person that can answer it. So sometimes they come find me or Kamal or somebody. Yeah, okay, so knowledge base, that's great. Contact us. This one has, like, if you have an issue with your account, or if you want to, you can create a Jira ticket, basically, which happens in the background, that will create a ticket in our ticketing system. We'll answer it. Something that you don't want to ask on the forum. You don't want to say, here's my password, it's not working, kind of thing. Office hours, we have a way where you can, like, book time with one of us. I think there's like 25-minute sections. So if you just want to have a conversation with one of the developers or somebody that knows about teaching on Fabric, or somebody who knows about whatever, you can click there and you can book an office hour. And if you have questions about teaching, you can actually ask us to create a project for you. Yeah, and then experiment issues, that basically kicks you off to the knowledge base in the forum, because the whole point of this was to try to make it so that you don't use this. You don't use the ticketing system for simple questions. Oh yeah, and I totally forgot about this. Down here in this corner, This is brand new. We just released it like 2 weeks ago, which is why there's not a slide about it. But this is just an AI chat box. So you can basically say like, how do I create a bastion key or something like that. And it'll just come by, and it has a RAG that has learned about all our documentation, and it'll tell you stuff. One thing we have noticed is that it doesn't like most chatbots that you've dealt with, that'll come back and tell you line by line. This waits until it has its whole answer and then gives it to you. So it seems like it's really slow, but it's the same speed as everything else. It just won't tell you the answer until it's totally done. We actually borrowed this from the Access project. They have one that's exactly the same. So you can see here, it just kind of says how to do it to create your bastion key if you want, and how to register it with Fabric and install it. And then it also tells you what sources it got that from. So if you want to go read the documentation about it. So this is pretty useful, very new. So like, you can definitely ask it questions it doesn't know the answer to yet. We're working on it. All right. Everyone got to that? Everyone ready? Everyone ready to try to submit something? Okay. This is the most exciting one. So this is the Jupyter Hub. So if everyone wants to, you can go click on Jupyter Hub. This is going to ask you to log in again. So when you do this, you'll log in with your institutional identity again. Everyone's already done this, it looks like. On here, we wanted to have like one version of this, but a bunch of educators, they like to have things be stable for longer than we want them to be stable. So we have a bunch of ones up here that are more stable for a long time. This is the current released version. And then this one just checks out of our GitHub and installs it. I always use the one that's from GitHub because it almost always works. If it ever doesn't work, I can just go back one. So for now, just use the Beyond Bleeding Edge. I'm certain it'll work. It's really intended so that educators can have a consistent platform to develop their educational tools on. Because when you have a class of 300 people and something goes wrong, that is a bad day. So when you launch this, this is actually running on our Google Cloud Kubernetes cluster. Because you're all hitting go right now at the same time, it's probably elastically expanding itself, which sometimes means it takes a little bit longer to launch. It usually doesn't. Usually it takes a minute or something to launch your cluster or your container. So each of you get your own container on here, and it'll have your own private space. Doesn't have too much storage. It's not very powerful, but it's good for the kind of stuff we're doing today. Like I said, whereas the kind of stuff you would do for a classroom setting, if you're going to do a really complicated experiment, you probably want to figure out how to take our FabLab library and put it into VS Code or whatever you use. I should have launched this earlier because now it's going to take a minute. But any questions while we're waiting for my Jupyter Hub to come up? Oh, there it goes. Any questions? Has everyone else already gotten this far? I'm winning? Okay, that's good. Actually, I'm not. This isn't a win yet. You've all used Jupyter Hub before, I assume. Yeah. There you go. Okay, so this just looks like Jupyter. I'll wait a minute until most people have something that looks something like this. Or maybe I'll just, okay, I can give a little tour. Everyone uses it. Anyone hasn't used this environment? We stumble upon some people. It's very powerful. But okay, so just as a little tour, what you'll have in here, by default, I have a few extra things. I, in fact, hid a bunch of stuff too, because I usually have a whole bunch of garbage in here. But what you see here is that there's a couple main things that you want to look at. One is you're going to have these two Jupyter examples folders. Jupyter examples.main actually pulls from our GitHub a bunch of Jupyter examples that are the latest, greatest, current ones that are in our main directory. The one that's labeled 1.9.0, that's our current released version of the examples. I generally just use the main ones, but if you want to make sure that you have access to older ones, you can actually go straight to our GitHub and just get them if you like. If you go here and open this, you'll see inside here, there's some example notebooks and some folders. The one you really have to care about is this one called Start Here, and it basically tells you what to do. You start here, and let me get rid of this down here. I don't want that. So what this is not really, it is a Jupyter notebook, but it's basically just an index of a bunch of other Jupyter notebooks. It's not a Jupyter notebook that you would generally run. People, I'm just kind of glancing. Yeah, okay. I'll just talk about this and then you guys, I'll give you time to catch up here in a minute. So if you look here, there's some instructions basically. The GitHub repo that all of this is in is right here. So if you wanted to go check out the GitHub repo and all the examples, the top little section is getting started. There's two main things here that you have to do. One is configure your environment. The main thing about configuring the environment is you might be in multiple projects. So you have to kind of tell us which project you want to use today because we can't know that. The other thing is if you haven't used it before, you don't have any of your Bastion keys or regular keys or any of that kind of stuff, the configure environment will create all that for you. You don't have to do anything except hit play once and it'll just do it. And then this other one called Hello Fabric is the Hello Fabric notebook. I'll wait before I go run the, I'll talk a little bit more to make sure everyone gets caught up. I see a couple of them have worked, but so then down here, I'll come back to the configure environment and the Hello Fabric in a minute as soon as I think everyone's caught up. But we just have a long list of examples on how to do all sorts of things on Fabric. This was the original way that we were kind of communicating the documents on how to use it. We really prefer the artifact manager now, but so many people are used to this, we're probably never going to get rid of it because it's just always going to be here. And we try to keep them updated, but the artifact manager is easier to keep updated than all of this. If you look here at the examples on how to like find available resources, delete your slices, list all the slices you have, save slices, add and remove SSH keys, modify them, creating SSH tunnels, using different kinds of storage, how to use a GPU, bunch of different crazy networking things. We're going to do that in the next section. FPGAs, P4 slices, some interesting ways to do your configuration. And down here we have some what we call complex recipes. So these are some people that have done some interesting things. There's an FR routing OSPF example, Open vSwitch, iPerf, connecting to Chameleon via facility port, a bunch of other just interesting things. How to do Grafana and Prometheus, Kubernetes cluster, Tailscale, which is like a really cool way to use Fabric. I can tell you about that in a minute. And like that. So if you want to start, like after you go home tonight, the first thing to do is maybe just go through a bunch of these and just start learning about them. We're going to go through the Hello Fabric one and a couple of the networking ones in the next hour or so. So is everyone somewhat caught up? I'm going to go in here and jump into this configure environment one. So if you click this configure environment, actually yours will look like this. I was playing with this earlier. Yours will look like this when you see it. I'm going to clear all my outputs so you don't see anything else. You can read about what this says, but I can just kind of tell you what you have here. You go back in the main work directory. There's this other folder here called Fabric Config. And inside this folder, you won't have very many things in here. Like you won't have any keys or anything like that. Mine already has it because I've already run this before. So you'll just have a few little things in here. And then what you want to do is in this Jupyter Notebook cell, you want to add the project ID of the project you want to use. But since you guys are all in the tutorial projects, we've hard coded in the project ID of the tutorial project. So all you have to do is come down here and uncomment this line that says project ID for tutorials project, and optionally comment out the other one. And now that is all you have to do to make it work with the tutorial project. Once you get your own project, you have to come back here and replace your project ID right here and rerun this, and it'll configure this all for your project. Then all it does is show your configuration, verify the configure, and then save the configuration. So if you just hit the double play button up here and say go, it'll just do everything for you, right? And if you really want to know what's happening, if you look into this Fabric config directory, it's mostly manipulating this Fabric RC file and then creating keys. So if you open up the Fabric RC file, there's a bunch of just things that you can configure. Once you get more advanced, you can manually configure some things in here, but for now, you don't really need to do much of anything. You just need to click go. And you can see the interesting thing here. It prints off your configuration. So this is showing you like all of my configuration, what version of software I'm using and various things. If you ever have problems, one of the things we'll probably ask you to do is print this off and send it to us, and then we can see if your configuration is crazy. But it's probably okay. And then here, it just verified my configuration and then saved it. You can see that like this was updated 52 seconds ago. So it's good, right? So does everyone get this far? No? Shall I wander around the room real quick? Oh, then it's creating it. It probably did create it. I think it says it doesn't exist, and then it actually creates it for you. So you're probably, yeah, mine says it's valid and is there because it was already there. It didn't actually create one for me because, all right. Should I give everyone a few minutes? Has anyone gotten past that spot? Do you have questions over there? Should I walk around the room? Oh, yeah. Or you can just uncomment that from one minute. Okay. Anybody else? I've done this a bunch of times. There's always like a head of people. Yeah, that's right. Maybe I'll tell them to make a better message there. Okay, so it looks like at least everyone in the room is mostly there. If you want, you go back to the Start Here menu. And then what you can do is you can hit the Hello Fabric example. And that'll open up your example here. What this is going to do, which is kind of cool, we're trying to move towards this, is have all of the different, so this, I'll just back up a little bit. Oops, let me clear all this again. I was running this morning. Okay, so what this does is it'll take you through the steps of creating like the very simplest experiment you could possibly do. On the first step is configure your environment. You've already done that. The next step is it's going to import the FabLab manager and create a FabLab manager object, and then show the configuration. So if I run this, it should create that, and it's going to just show my configuration again, like you've seen. And it says everything's valid and it works and so forth. The next thing, now that we have this FabLab object, so this is the FabLab manager object, there's a bunch of things you can do on it. So one of them is list the sites. So I'm going to click play here, and this is going to take a minute because it's actually going to all the sites and getting all the information about all the sites and what resources are available everywhere. And then you're all doing it at the same time as me, so that's even worse. But in a second here, we'll see that this will come back with a big pandas table that'll show all the state of all the sites and what ones are available and active and so forth. While that is happening, I will talk a little bit about the next section down here, which is where we're going to create the actual first slice. Actually, I might explain this a little bit differently. You guys are very experienced, so when I do this is not going to be new to you. Maybe you will, I don't know. So you realize this is a container for you, And in this container, you can just run terminal windows, right? So what I'm gonna do is hit this plus button up here and open up a new tab. And then I'm gonna take that tab, I'm gonna drag it over here. And then I'm gonna hit this terminal button in it. And what this is gonna do, did I click it? Do it. Okay. So what this is going to do is just create a terminal that's in the container in my Jupyter Lab instance. I'm not sure why it's taking so long. I also sometimes like to create a second one, and I drag it down here, and then I have two of them. I really don't know why it's taking so long, but that's okay. And now I have, this is kind of how I like to have my setup when I use this. So I'll have two terminal windows, and then I'll have my experimental notebook. And then we can log into things over here and run things, and we can kind of see our notebook over here and kind of bounce back and forth. I think everyone's hammering on this right now. Okay, so there we go. So, and now this, if you see, this is just a terminal window on the container that is running my Jupyter notebook, right? And everybody is running list sites at the same time. It should come back, and it usually takes like 30 seconds, maybe a minute, but it's been taking a long time. So we'll see what happens here. I'm just gonna be quiet for a minute and let it catch up to me. Anybody else further along? How are the people online doing? Is anyone monitoring the chat? I haven't had a chance to. Sure, this does work better when there's not a whole bunch of people hitting the same button at the same time. But everyone's gotten this far, right? Where you can, okay, I'm very impressed. I think Michael was in the background fixing things in a very good way. I'm starting to get impatient with my list sites. So I'll talk a little bit while this is going. The next cell here that you'll see, this is when you're actually using the FabLib library. So in this case, so you're taking your FabLib object, FabLib manager object, and in this case, you're gonna say new slice, and you're gonna just give it a name. So it's all by default my slice. It's totally fine that each of us has our own slice called my slice because the namespace is per user. If you wanted to create a second slice that was called my slice, it would give you an error and say the name's already used. So you personally have to have different names for all your slices, but we can all share the same name across that. So this is going to create a new slice. It's not going to create the slice, it's just going to create the model for the slice. And then we can start modifying it and then eventually submit it. So then the next thing we're going to do here is you say slice.addNode. And you're just going to name the node. And then it'll create the node. We're going to get back on the object that points to the node, but not do anything with it. And then the last thing we're going to do is slice.submit. So we're going to actually commit the changes we made. So we created a new slice. We added a node. We didn't say anything fancy about the node at all. We just declared that it exists. And then we're going to submit it. Okay. I feel like I'm being antsy and I want to hit cancel. But if I do that, it's going to start all over. So maybe I should wait. I'll come up here and show you this actual add node here. You might notice that you're not actually saying anything interesting about this node. You're just saying, give me any old node you want. It's because there's a bunch of defaults that kick in, but you can actually control a lot of different things. So if you go up here to the top, see this list of API references? If you go to the add node one and just click on it, this takes you to the add node method in the documentation. So you can see up here, you can actually give it a site that you want to have it on, or you can give it the number of cores you want, the RAM, the disk, the image type you want, a bunch of other things that you can have on there. Now, by default, it just picks sane defaults. So you get like a Rocky 8 Linux, I think by default 2 cores and 8 gigs of RAM and 10 gigs of disk, and it chooses a random site for you among the sites that are active anyway. So we should all get a random different site. Does anyone get the list sites to come back? You just got it? Okay, they're all gonna kick in a minute. Because I think when a bunch of people do it at once, it tries to coordinate it and do the query once. That's what they told me that they updated that. Okay. If you want, you should go ahead and just run the next cell. Whoops. I'll just run the next one here too. Hopefully mine comes back soon. Any other questions? People just waiting. Yeah. I can. Oh yeah, yeah. So what I did is you can hit the little plus button, and it'll create a new window or tab, and you can just take that tab and you can like make a new split it or like that. And what I like to do, and it's up to you, is I like to have a couple terminal windows on the side here, and that I can use, and then I can have my notebook and I just kind of bounce back and forth. So you can see here, so my list sites came back. You can see we have all the sites listed here. All 30 whatever of them are active. And then you can go across here, and this shows the different capacities and availability of different types of resources like disk and RAM and cores and ConnectX 6 cards and different kinds of GPUs and Bluefield NICs and so forth. So if you wanted to look at this table, you could actually find out how many of all the different resources are available. I went ahead and submitted my other request. Oh yeah, it's going. I'm going to show you here. So this list sites is another one that has some interesting parameters to it. So if you go up here to list sites and you open up the list sites documentation, you can actually see that this actually lets you do a bunch of filtering. So you can say list sites, and you can create this filter function, and we'll show you that in the afternoon session. Filter function that will actually, you can say, I want a site, but I only want one that has at least 2 GPUs available because I'm going to use GPUs, and I want this much memory available and so forth. So you can do these filtering to actually get the resource, to use this tool to find a site that has the resources available that you want in an automated way. So it's good to go look here and see how that's working. All right, so hopefully this has gone through by now. I should have done this earlier and then got ahead of you guys. I think I'm not the first one in line, that's for sure. So I have submitted the slides. It's trying to submit the slides. It's going to come back with like a status report. It should take a couple 100 seconds to boot this node. Any other questions? People ahead of me? Until I remember to kick you out. The last people that we did from the workshop last month, I kicked them out right the day before I got on the plane to come here. So that's about how long it takes because I don't remember people that But don't worry about too much. There's plenty of people in this room that can are eligible to create projects. So yeah, we should create multiple project leads, and multiple projects should be from the people that are at this event today. But we just have to figure out who's the right people. It can't be students. That's the only rule. Maybe we should have done this faster so that I would have been ahead of the line. Has anyone gotten past this? I wonder if there's another class that's particularly slow. That's what I usually do. It doesn't work very well. Everyone can There's another cool trick I'll show you since we're waiting. Maybe you guys know more than me. So if you go to settings, you go down to the settings editor, and you go to this code completion. If you check these two boxes, you'll get code completion inside your thing, and it knows all about our library, so it'll just do the right thing. So try that if you want. It's not on by default, so you have to turn it on like every time you start it. So that's settings editor, code completion. All right, I'm getting very impatient, but I'm tend to be the person who just flashes on. I honestly don't know. This is like the only one that I think that's probably all of them. I mean, maybe it's called something different. I do know that there's a ton of different. Jupyter allows is expandable. You can add all sorts of crazy stuff to it. All right.
If you were to teach a class using Fabric, what would like the lead time be? Like a couple of weeks ahead of time?
It's probably up to you. You like if you're going to teach a class with me, you probably want to make sure you're very well versed with a lot of the like debugging, especially because the students are going to, students, right? If there's something that can't go wrong. Yeah, so I'd say like I would suggest a semester. Like you should probably spend a bunch of time, especially with your and make sure everyone. Is he still working? There are a lot of things. Oh, yeah. All right, so I'm Python. Never worked. For all of you, this is what it'll look like once your slice is submitted, and you can see what it's doing here is that I think it's every 20 seconds it queries again to get the current state, and it has a little piece of information about like the name of your slice, the ID of the slice, the expiration date of the slice. So this is interesting. I didn't say this before, but these slices expire. This isn't like Amazon, like we don't have your credit card, so we can't just charge you forever. So when you submit one of these slices, it has a length of time. You can configure that when you start it, but if you don't configure anything, it's 24 hours. But you can do it up to 2 weeks, and then you can extend them if you want. There's a whole process for doing it. So just know that if you start a slice today, in 24 hours, it'll be automatically deleted unless you do something to like make it longer. Says who owns it. It also says, yeah, and then so that's the slice information. There's also the slivers information. So a slice is like a group of resources that are doing one thing. When you do this slice.submit, you're creating a slice. Each resource in the slice is a sliver. In this case, there's one sliver. It's AVM with default parameters set to it. You can see here, I didn't ask for anything in particular. So the slide I got happened to be Tokyo. That was just completely random. It's trying to find a node that has space on it and is active out of the ones that are available. So here I got Tokyo. And you can see every 20 seconds or so, it's refreshing that. As soon as it's done, which usually takes about 200 seconds, those yellow lines will turn to green and it'll be like stable okay, and I think active is what it says for ticketed, and then we'll have more information about it. So is anyone else this far? Yeah, okay. I suspect that took so long that I suspect that Nick Sultana from IIT, Illinois Institute of Technology, I think his students must, they do very disruptive things. They like to submit like, you know, hundreds and thousands of slices at a time and they do a bunch of monitoring for us. It's really cool what they're doing. But when they are in the middle of something, sometimes it goes weird. Okay, so now you can see mine's stable okay. That means we're all ready. It took 183 seconds once it got submitted. Stable okay is good. Green is good. You can see now that I can scroll this way in here and I'll show you what this says. So you can see, and you can also see that it's now running a post-boot config section that took 3 seconds. That's because we didn't tell it to do anything in the post-boot config. We'll do some of that a little bit later. But you can see here that I have a node, has 2 cores, 8 gigs of RAM, 10 gigs of disk. It's Rocky 8 is the image type. You can specify other image types. Ubuntu is pretty popular. You can see that I'm at Tokyo, but I'm specifically on the Tokyo worker number 2 is the host I got. You can see that I have a management IP. Unfortunately, I got Tokyo, which is one of the IPv4 sites, one of the like 5 of them that exist. It's kind of interesting to show people that IPv6 stuff works. So probably you got an IPv6 site, but it really doesn't matter. These are default cloud images. So because Rocky Linux, the default username on Rocky Linux default cloud images is Rocky, that's your username. That's the management IP, so that's on the management interface. This is the SSH command. So one of the things we did, because we've configured all the keys for you in that configured environment, and we set up this SSH command to print here. So you can just copy this, paste it over here in the terminal, and this is going to SSH through the Bastion host into that node, right? And otherwise, you can kind of go look and see like what we're doing there, but really you don't have to do much. So you can see I'm over here. I'm in node 1 right here, which is my node, which is kind of cool, right? And you can see that if I did like, you know, what is this, like ls CPU, that'll show me something, right? Oops. You can see that I have, pull this down a little bit. Oops. You know, a pretty basic machine that has a couple CPUs and not much more than that. You can also see if I say IP address list, you can see that I have, drag this a little bit over so you can see it better. You can see that this has, you know, a loopback interface within one interface that's on the management plane. And you can see that in this case, because I have an IPv4 site, this is actually a local address that is using NAT to get out, but the OpenStack has forwarding rules to make it so that we can SSH to it. If you were on an IPv6 site, you'd actually see the IPv6 address right there of the management IP that you saw here. Yeah, so I'm just in there. I can do whatever I want. I have root. I can, you know, sudo su minus, and then now I'm root. You can do whatever you want, install whatever you want. You're good to go. The next thing that's in the example notebook, we're a little bit past time, but that's okay. Is you can say slice.show or slice.list nodes, and that basically shows you that you have this slice and there's functions you can call on it that will show you information about it or list it. Any object in FabLib has a show to show its state and a list something. So like if you have a node, you can say list interfaces or list, you know, components, and you'll get a list of all the things. I'm not going to do that, so I can show you this. Let me get rid of this because this was me playing with it earlier. So then what we can do, and I'll just run this to show you how this works. Oops. Oh, I didn't mean to run that one. I mean to run this one. You can see what I'm doing here is I'm looping through node that, for all the nodes in slice.get nodes, in this case, there's one node, and it's going to say node.execute. So what this is going to do is just execute this bash command on the VM and then return, it'll print it out, the answer, but it'll also return standard out and standard error. And what this should do, and you can see that it did it, it's going to say hello from node, and then it's going to have the node tell it its host name. So you can see mine says hello fabric from node 1, which is what it is, right? You can also do, and this is what I was going to show you. Once you get there and you can play with it, you can do things like, if I say node equals slice dot, and you see my tab completion is working now. So if you turn on the tab completion, you can get this. Get node, right? And you can see here it says, oh, get node, this is what it does. I can pass it in a string of the name. So I'm gonna say node.get node, and I'm gonna pass it in node 1. Then I can say node.execute. And then you can say like echo hello into oops. That I just can't type. And then if I run this, that executes. You can see what it's going to do is it's just going to run that command on the node. And if I look here, you can see there's now a file called hello. And if I cat it, it says hello inside. One of the other things you can do, and this is what it's really often used for, is you can say things like node.execute, and you can say sudo dnf update. It gives you -y, right? And you can say, and I'll just test here. So if I wanted to do vim on hello.text, it's going to say that it's not found. But if I say dnf update and I say sudo dnf install vim -y, because this is like, you're not watching this. If I run this, and then you'll see, and I'm going to select here so that it doesn't scroll off the end of the world. It's going to just do a DNF update, install some things. You can use that to like configure whatever you want to configure. Right, that's kind of the main way to do it. There's also a node.upload file or upload directory. We use that a lot, and you'll see that in some of the other examples because we tend to put we tend to put a lot of configuration in a folder, and then we just say node.upload and then kick off a script, and then it'll configure the whole thing. Right. All right. Is everyone close to this far? We'll go on to some networking things. Anybody have any questions about any of this? Feel free to just bang on this and play with whatever you want. You can't break it, or if you do break it, like I say, that's a good thing. Right. The other thing to note is that this slice.delete at the end will actually delete this slice, which you'll want to do, especially if you're using a lot of scarce resources, GPUs, etc. Is everyone this far? Anyone want me to slow down? Or am I good? No? You're good? Okay. I'll let this do its thing in the background, but I'll skip over here. This is where I'm gonna grab this one. Yeah, we'll do the networking. All right. Okay, so I'm gonna start talking about some networking things. I can make this bigger. All right, so everyone got a feel, you've all created your slice. Has anyone not been able to create that slice? Is it because it's broken, or is it because you're just waiting? Yeah, somehow you submitted one and then it's in there somewhere, but I'll look at it later. But that'll probably work. Okay, so that was interesting. A little bit like basic. Hopefully, you get your hands dirty. You know, I don't know how to create a VM. You know how to SSH into it via the terminal inside of your Jupyter Hub, but also You can use some of the basic fablib commands to execute commands on your VM to configure it, but you haven't seen any sort of interesting networking yet, okay? So this is all the same pictures as before. So I showed you the management plane versus the data plane. So of course, you kind of understand this bastion hosting. Can't get in from the external attacker, but you can now have your data plane. So what we're going to focus on for this is we're going to create a couple simple data planes that you're going to be able to use to create a couple of VMs on different sites and then have them connect to each other. Right? If we have time, I can show you an iPerf example. Okay. Okay, so here's a bunch of data plane services that we have available. So there's L2 bridges, point-to-point links, site-to-site links, facility ports, FabNet v4 and v6, the explicit route options, and port mirroring. I'm going to go a little bit faster. This is kind of the list, but here we can show you each example kind of in depth. So this is what you already did, right? So you created a VM on a management network connected to the public internet, no data plane, and that worked. And then you were able to SSH into it and do some basic things, right? The next most simple, or the next more complicated, I guess, example is what we call an L2 bridge. So this is like creating a switch that's on one site. So what you can do here is create a couple of VMs. They'll both be connected to the management network, but you can create an L2 bridge that's basically just a switch. You can add a component, or a component in this case will be a network card, and you can connect the network card to the bridge. And then there's various ways, at that point you have an L2, like an Ethernet. You can configure the IP addresses and stuff any way you want. Although Fablib has a bunch of tools that make it easy for you if you don't want to do it the hard way. But if you really want to be complicated about it, you can do whatever you want here. So it's user-controlled layer 3 configuration, limited to a single site. So when you create an L2 bridge, all the VMs, you can create a bunch of VMs on the same site connected to that bridge, and they can talk. It's like you have your own personal switch, right? Okay. The next more complicated one is what we call an L2 point-to-points service. So in this case, you have two VMs on different sites. They each have a network card with a port, and you can basically say connect the two ports on those two VMs together. And the ports are going to be components that are, a network card that you've assigned to this VM. And you basically say connect these two with a single point-to-point service across the wide area. You don't really have to know about the wide area part. You just say connect this port to that port, go, and it figures it out for you. Again, since this is basically an Ethernet connection, you have full control over what you do at layer 3. So you can configure any IP addresses you want, or not use IP at all if you don't want to. So this is the purpose of sort of connecting between a pair of VMs on different sites. You often, this point-to-point link, you use it for like things like routers or switches that you want to like have deployed out in the internet. So that goes across the infrastructure depending on where your two sites are. You have a question like, what path does this circuit take? So something I didn't really mention before is that all of our sites have these Cisco NSO switches, and they're controlled by a centralized controller that's called NSO. And so when we create this, by default, Cisco NSO just picks the best path that it thinks. So if you don't care what the path is, you can just say, pick the best path, I don't care, right? But if you do care, there's another feature we have that I kind of hinted at earlier. We have this other service called a L2 site-to-site service. So what this is also an isolated Ethernet layer 2, but on either end, you have what looks like an L2 bridge. So it looks like two L2 bridges connected together. So you can have as many VMs as you want on this side and as many VMs as you want on that side, but it's limited to these two sites. And that's one Ethernet namespace. So you can, as long as you use the same subnets and do the right thing, they will be able to talk. So that's a totally different service. One thing that's slightly different about this than the point-to-point links, the point-to-point links, you can actually do the quality of service guarantees. You can ask for a certain amount of bandwidth. With this, we don't have, the technology doesn't allow us to provision bandwidth for this. But this is an easy way to create a shared Ethernet across two sites for some things. So the FabNet v4 and v6. So this is a very different thing. So these are, you can create VMs on a site and you have a local bridge there, but the bridge is a special bridge because we, like the Fabric service, creates a router for you or a gateway, and then we tell you, here's your subnet that you're assigned in your gateway, and you can then assign IP addresses from that subnet and have them and set the gateway correctly. And then the VMs that you have can send traffic out that router. Again, you have a management network and a data plane, so you have to be very careful about specifying your routes so that you know which traffic you're sending which way. Pretty easy to cut yourself off from the public internet if you don't do it right. Typically, there's some examples that show how to route all the traffic that could go to any of our FabNet networks. You can just route all that traffic there. We can show you an example of that. So what this does basically is you can create VMs and very simply create these bridges. You don't have to worry about the routers, like the tools, the system creates that for you. And then you can have VMs on separate sites that are talking to each other. You can have any number of sites all working together, communicating over FabNet. And you can also have your VMs talk to other people's VMs that are on FabNet. So this is like a public internet. It just happens to be confined to Fabric. Right? Really cool aspect of this is that you can choose when you create this to use FabNet or IPv4 or IPv6. So if you want to learn about IPv6, this is a good way to learn about it. Right? So you can just invoke it, use it, and kind of get a feel for how it works. For the most part, this is one of the more common ways. If you don't care about the low-level networking part, this is probably what you want. Oh yeah, and we have another thing that we don't really say too loudly, but we have a way to make this peer with the public internet if you really need it for some experiments. That opens up a huge security hole in our system. So if you want to do that, we vet you pretty hard. The way we say it is like, if you're gonna do that, we want you to have security protocols in place that are equivalent to if you're doing this at your house or your campus or something. Yeah. Facility ports. So this is kind of mentioned this before, but this is a way to have things inside of Fabric. You can have a port on one of your switches or on one of your VMs connected to a layer 2 circuit that goes to something that's outside of Fabric. And you can imagine that being a telescope on the top of the volcano, whatever. And you can just have direct layer 2 connections to it. ERO, so this is the explicit route options. So this is the way, like I said, if you create this link directly, you don't choose the path. But if you want to, you can choose the path with ERO. And so you can sometimes have multiple links between a pair of VMs that have different paths, and you can choose which one to use for various things, depending on whatever you're looking into, right? And it doesn't have to be straight. It can be all crazy, right? So these are like that. Also add on here is that if you want quality of service guarantees, you have to have ERO. There's no way for us to allocate bandwidth across the various links without you explicitly saying which links you want to use. But for QoS, probably what you're going to do is pick like some direct path and try to get the bandwidth guaranteed across it. Port mirroring, this is pretty cool. Like we have a bunch of users that do this. So if say you have an experiment that looks like this, a couple of VMs and a L2 bridge, but you want to monitor your own experiment, then you could actually do like this. So you have traffic going between these two VMs. You can create a listener VM and you can mirror traffic to it. So you can actually do port mirroring of your own experiment. And for some special people, you can do port mirroring of our underlying systems. So that's what some people are doing. Yeah, you had a question? No. So that's all possible. Infrastructure port mirroring. Yeah, you can do infrastructure port mirroring. So if you want to look at if you have a research project that is actually looking at research infrastructure and how it all works, we actually allow some projects, very special projects, to monitor our infrastructure using this port mirroring as well. Okay, so there's that. So those are the different types of networking things you can do. Now we're going to go back to our Jupyter Hub that everyone's all already in, I think. Let me exit out of my node here. And what I'm gonna do, I'm gonna do it real fast so you guys don't get ahead of me. I'm gonna go down here to this networking, and I'm gonna go to the IPv4 layer 3, and I'm going to do the fully automatic version. And then I'm gonna go down here and I'm gonna cheat. This is a common thing. I'm gonna comment out the delete at the end, and I'm just gonna hit run all, and then it'll run it all and it won't delete it. But I'm gonna show you how what it's doing along the way. Hopefully I'm ahead of you now. All right. So this is just my config, and what we're doing here is this is the Fabnet v4 IPv4 network fully automatic configuration. So this is going to create 2 VMs on 2 different sites, connect them to the Fabnet v4 routers that we have and we control. So you're just going to get a gateway and a subnet assigned to you, and this is going to fully install it and everything for you. And you'll have 2 VMs, different hosts that can talk over our layer 3 internet. And I'm going to show you how this works. So step 1, oh, this isn't going to work because my other one is still up. Let me see if I can save it. I'm going to go to my slices. I'm going to delete the one that I have called my slice. Delete. Okay, boom. Okay, I just deleted it. Hopefully I got it in time. I don't think I did. I think this is going to fail because I already have a slice called my slice. Maybe it'll work. I don't know, maybe it'll work. So what this is going to do, a lot of times what you want is to have a couple sites, but you want to specify them yourself. So if you look here, down here when this looks familiar to you, say slice, my new slice with a slice name. In this case, I'm calling it my slice. And then I'm going to say add node. But in this case, you see I named it, but I also added the site parameter, right? So this site parameter is going to come from somewhere. I could actually manually type New York or Hawaii or whatever it is there. But what I really want in this case is I want to have 2 different sites that are on different places. I want to make sure they're different. So in this case, we have this function, this fablib function called get random sites. And it's going to say, give me 2 random sites. And I don't care which ones, so just 2 random ones, right? In this case, I got SRI, which is in the Stanford Research Institute. So it's in the Bay Area, and CERN, which is in Switzerland. So that's what I happen to randomly get. You'll get 2 other pairs. Hopefully we don't have too many in the same place. Then I submit it. You can see it's already submitted. Then what I'm doing here is I'm saying add Fabnet in this case. So what this is going to do, it has a bunch of extra steps in it that's doing a bunch of automatic things for you. So it's actually going to add a component to each of the node. And the component in this case, because I didn't specify anything special, is going to be what we call a basic NIC. And a basic NIC, if you guys are familiar with SROV, so we have dedicated NICs. So you can get a ConnectX-5, ConnectX-6, you can Bluefield. There's a whole bunch of types of NICs. You can get the full NIC allocated to you. But there's not that many of them, not enough for like classrooms worth of people. So we also have SROV, which is single root IO virtualization. So in the network card, the card itself can divide itself up into a bunch of PCI devices. And we have, in this case, I think it's 128 of these available per host. And if you want a basic NIC, you basically will get an SROV virtual function. It's limited to 100 gigs of network traffic, so it's quite fast, but it's shared amongst everyone else that happens to be on that host. So often you can get close to 100 gigs, but if someone else is doing something, you will be sharing with them, right? So in this case, this add Fabnet automatically does everything for you. If you wanted to look at the IPv4 networking, or IPv4 layer 3 networking, and looked at one of the other ones that was like manual config, you can actually see some of this broken down in different steps. I probably should have actually done that one. I was trying to go too fast. Let me see if I do that. What happens? I'll just let it go. And so you can see the SRI one is already active, but we're now waiting for the CERN. So in this case, I have slivers, I have 4 slivers. In this case, there's 2 nodes, each of which are slivers, and there's 2 network services, one of which is a FabNet v4 service that's at CERN, and one is a FabNet v4 service at SRI. And the respective nodes are connected to the respective network. And so we see CERN's network is still working on it, but it'll probably get there in one more turn. Also interesting, what happens here is because I use that automatic networking. Okay, so now you can see. Let me move some of this out of the way. Well, this is a good example too. So I have an SRI as a IPv4 site, but CERN is an IPv6 site. So you get 2 different kinds of management IPs. You can see I still didn't specify anything for the cores, RAM, or disk, or image, so I'm just getting the default ones. You can see the hosts that I happen to get, the sites that I happen to get. They have 2 different SSH commands. So what I can do now is I can paste this one in here. Oops, I hit it. That might actually work. Let me see. And then I'll paste this one down here. And you can see that, you can almost see it, but it's, oh, you can see it. I just can't see it. I'm seeing a bunch of Zoom stuff is in the way. Let me get this. Let me get that out of the way. It won't let me do it. But at the top, I guess. So you can see now this is in node 1 and that's in node 2. You can see also that the post-boot config took 17 seconds instead of the 3 that was in the last one. That's because the post-boot config is actually configuring the IP addresses in here. If I go in here, if I did like IP address list, you can see that I have an extra NICs in here. So the IP. Right. So you can see both of these have ETH1, which is their default address. You can see in this one, you actually get the valid IPv6 address, where I think that one's actually just, that's the link local one. And here you can see this is the external one. Here's the 2001 address there. And then you can see they both have an ETH1, which is configured so they both have a .2 at the end, because the 10.141.133 is what was allocated to the what is this called? The network service. So if you look here, so I got 2 VMs, I got 2 networks, right? One at CERN and one at SRI. And as you can see, the subnet that was assigned to the one at CERN is 10.143.4.0, and the gateway is 10.143.4.1. So if we look over here, that the IP address that it gave to node 2 is 143.4.2, because that's just, that subnet plus 1. And if I did IP route, I think it's list, right? You'll probably see here that there's a 10.143, so forth, is being routed to 10. Where did it go? Oh, it's up here. 10.128.0.0/10, which is that's the whole space of the entire subnet that we've carved out for FabNet v4. Anything that wants to go to that is routed to this gateway, right? So you can see that the network was assigned a subnet and a gateway, and then that was put into the node it's for you. Same is true up here. This is 141.133.0 and so forth. And you'll all get a unique one. And you'll never have to share. So you get a /24 here, and you can do kind of whatever you want with it. You can also see we have the interfaces here. These are like the MAC addresses of the interfaces and the IP addresses that are assigned and so forth, right? So in here. So then what I can do, if I wanted to, I could say, ping, where did it go? This one, oops. And you can see that it's pinging. You can see that it's 165 milliseconds because one of them's in San Francisco and the other one's in Switzerland. So that's a pretty reasonable round trip time for that. And then if you use, I think this will work. I don't know if this will work. So if I do trace route, trace path, you can see that it only goes through sort of like things that are in our 10 dot whatever address. So this is the route through our FabNet that it took. So none of those are like public ISPs or anything like that. It's going through our network alone, right? Everyone get this far? Anyone who's trying anyway? Everyone tired? Then we have down here, we can run the experiment. So again, I showed you how you can execute things on the nodes. So in here, we get the slice and get a couple of nodes using a technique we used before. Then we can say get interface, and the network name of the interface, like so this command right here will get the interface from node 2, given the name of the network. If you look up here, it's just a pattern, like that's how it names the networks. Fabnet underscore IPv4 underscore the name of the site. And so if you get that interface and then you call get IP address on it, you'll get the IP address of that particular interface. And then you can say, since that's node 2's IP address on its Fabnet interface, you can say node 1.execute ping node 2's address 5 times, and you can see that it did it, right? So I don't know why there it goes. Okay. I could run that over and over again if I wanted to. So that kind of shows that that experiment works, right? Now, obviously we logged into it and did it ourselves too. Okay, so that's a very simple, like you just want connectivity, but you don't care how it works. You're not doing the routes or anything like that. I will jump over here. Anybody have any questions on that? Is it interesting at all? So I'm going to jump over here and show you how to do. So we have about 15 minutes, so we're supposed to have lunch. So I will try to do this quickly. But here you can look at, we have wide area layer 2 network. I'm going to click on this one, but this time I'm going to do it completely manually. Okay, so I'm going to show you how this works. Again, I'm going to cheat, and I'm going to go down here and hit delete, comment out delete, and then hit play, and have it do the whole thing, and hopefully I'm ahead of you. So this is showing basically a wide area network that's connecting 2 nodes together. In this case, it's going to pick a site-to-site link because you haven't specified any ERO or quality of service, so it's not going to give you the special stuff. What it's going to do here, it's again going to get 2 random sites. Again, I'm going to have to do this again. Here, stop. Slice, it's 2. Yeah, okay. I'm just making it a new name so that it'll not have an error for using the same name. And I'll get here in a minute. Okay, so okay, so now this is going to call this slice my slice 2. It's going to get 2 random sites. Again, I didn't specify what they are. We don't know what they're going to happen. Last time I got pretty good ones because they're fairly far apart. But this time, who knows? Then we're going to see is we're actually going to do all of this stuff kind of manually. And so this is a slightly more complicated example. So here we say we want a new slice. We're going to add a node, just like we said before. We're going to tie it to the site that it's currently trying to query for. And then we're going to add a component, right? So in this case, a component is almost always a PCI device. So you're going to say node 1, and you're going to add a basic NIC. You can see up here, there's a list of all the types of network components you can have. We need to add the Bluefield NICs to that list because it's not there. But a NIC basic is an SRIOV virtual function, like I said. So you're going to get just the virtual function. You're not going to get full control over the network card that you can offload to and do all the fancy stuff with. But for a tutorial like this, it's the way to go. So here you're going to say node.add component. You can tell it the model of the component, and then you're going to give it a name. It could be any name you want. In this case, I'm calling it NIC1. And when you add that component based on that type, it's going to have a certain number of interfaces. A SROV virtual function has one interface because it is more or less an interface itself. But if you ask for like a Xilinx FPGA or a ConnectX-6 cards, it'll actually have more than one interface. So then when we extend this and say, on that component, get the interfaces, it's going to give us an array of interfaces. And since we know there's only one in here, we're just going to take the 0th one and move on. But if you had a dedicated NIC that had 2 interfaces, you would actually be able to use them each individually and assign them different networks and things like that. But in this case, we only have the one. So in this case, it's going to add the component to node 1. It's going to add a component to node 2. And then we're going to come down here and we're going to say add L2 network. So in this case, it's add a layer 2 network. And we're just going to pass it in a list of the interfaces that we want to have connected to that network. And it's going to do the work to figure out, should that be a local L2 bridge? EDC is not the one I want, but that's all right. I think this will work. It's going to figure out if it's a local L2 bridge or if it's a wide area point-to-point link or what have you. Based on what it knows about those 2 interfaces and where they are, it'll actually deploy the right thing for you. And then, of course, you're going to submit the slice, and it'll do what it's been doing, right? You can see here that it's actually found 2 sites, EDC, which is actually kind of a special site that's at NCSA, has a bunch of storage in it. It'll be fine for this purpose. But generally, EDC is not a rack that you would use for general things. And then the rack that's at Los Angeles. So it's going to create the 2 nodes. But you can see there's only one network there, right? Because this is actually creating a site-to-site network service with those 2 interfaces plugged into it. Whereas the last time, each of the sites had its own network service because that network service was then connected to our routers, right? All right. This is going to take a minute. I'll let people ask questions. They're too detailed, they're too high level. People are already just, can never tell if I'm being too complicated or not complicated enough. Yeah, before.
And it kind of follows defaults and it's pre-configured. Is that the difference here?
Well, so the main difference here is this is doing a layer 2 network and the other one was doing the layer 3 network. So if I go back, that's a good question actually. So if you go back here on this FabNet layer 3, I picked the full auto, but you can also do manual with the FabNet layer 3. And if you did that, what it would do is it would, like, when you created the FabNet network on the site, it would actually have associated with it, it would assign to that network the subnet and the gateway, but it wouldn't configure your VMs with any of that. Like, it's up to you, because then you can configure it however you wish, right? And if you don't do that, if you say full auto, it'll just, like, for all your VMs that are connected to that network, it'll just pick them in order. But that might not be what you want, right? You might want to control that, so we don't have it do that all the time. So the manual, you actually have to run, like, if I click here, so you'll see in the manual version, when we get down to setting it, you're actually going to, like, node2.execute IP address add and so forth. So you're going to be doing IP or node.execute, and then you're going to be passing, like, bash commands to, like, install things, right? And if you go back over here with the one that's in the middle, it's similar, but you can say up here, you can actually say, you can add, like, routes, you actually kind of control it with our FabNet command. So sometimes you can get away with, you can say, like, so you say add the component, and then you say auto, which is going to automatically configure this interface based on the IP address that was added. But then you also have to add the subnet that you want, because maybe you don't want the full subnet, or maybe you want more. Like, some people like to do crazy stuff with the subnets, right? And then, yeah, I don't know if that makes sense. So, and you're also up here, you have to create the network yourself. So you're going to say add the L3 network, and you're going to have a net one, and then you're going to add, you're going to say net one that add this interface to that network and so forth. So basically, yeah, you'll have to get a feel for it. But basically, the full auto, you can just say turn it on or I don't care. And then the middle one, you can control it with sort of some fablib commands. And then the other one, it does nothing for you. You have to write your own execute commands to do everything you want to do. Right? And the same is true if you go to the layer 2 ones. We have like manual, auto, and user defined is what we call it. The same sort of thing. So manual, we do nothing, and that's the one I'm about to show you. And user defined, we have some basic stuff that'll do it. I lost, which one am I running? This one? Yeah. Yeah, okay, so this one, it's done. So you can see my 2 nodes, they came up. If I wanted to here, I could log in. And you can see here that this is a site-to-site link. So this network doesn't have a subnet or a gateway associated with it because it's a layer 2 thing, right? It doesn't know about layer 3 things, right? So you have to do it kind of all yourself. And you have these interfaces here, and it doesn't have any, the IP address it gets, you can see this is actually a link local IPv6 address that it just was there by default. It goes and finds it, but that's not a useful address for you to communicate with, right? And then if you come down here, you can say printing off the attributes and so forth. And then when you manually configure it, so this already ran because I was trying to like speed up so we can get done by noon. You can see that I'm actually going to create a subnet using this is just a Python networking object, right? So I'm just saying Python, create me a thing which is an IP4 network. I'm going to use 192.168.1.0/24. And this is going to give me a list of everything that's in that subnet without the first one, because the first one is .0, and that's kind of not really good to use. And then you can configure the node. You can come down here and you can say, get my node, get the interface that the name of the network. And in this case, I named it myself, so I know the name. And then I can pop off the first address out of that list that I created, and then I can say add that address to that interface. And then down here, you can say IP address show, and you can kind of see that it worked or didn't. Did it work? Looks like it didn't work, but let me see. Oops. This might have been my other slice, and now that terminal was kind of frozen. Uh-oh, what just happened? A disconnect from the Jupyter Lab. I got disconnected from everything. I think Jupyter Hub hiccuped. Let me get rid of this. I still have Zoom stuff. Might have to relaunch this. I might have to. Well, I guess I'll do this and launch Jupyter Hub again. Should pop up and connect to the same one, but I'll have to restart that slice or reconnect to it anyway. Not saying I can't. Well, yeah, what's going on? I feel like I got logged out and then it. See, I log on. Did you guys get kicked out? This seems like a CI logon thing. All right. Just trying now. I wasn't able to authenticate, I think. All right. And open up my start here. I'm gonna go back and open up the manual, this one, but I will not have, it'll still have the outputs there, but it won't. Okay, I'll call this my slice, I don't know, 3, and then I'll run it again. But I'm probably gonna run out of time. I'm not sure exactly what Sean, I don't know what Sean went. The plan is for lunch. Yeah, maybe his intention is to come back at noon, maybe. I'm gonna run that again. I'm not sure what happened there. I got disconnected from my Jupyter Hub. Let's set this up again. All right. What I didn't get to was another example, which is one of the networking examples that we tend to do is this iPerf example, but I don't think we have time to do that. I'm fine with whatever. I don't know where he said there's like some place you can walk to get lunch. Do we want to break here? Everyone seems like they're ready for lunch and tired. I think we should do that. We should break for lunch. After lunch I will show you the Olama example, which I'm hopeful that it works. And then later on this afternoon, hopefully we can have a discussion about your ideas of what you might want to use this for. And I'll take lots of notes. All right, and hopefully somebody here knows where we're supposed to go for lunch. All right, and everyone that's online, I guess we'll be back at, how long should this take? I think like 1:30. So we'll be back at 1:30 to everyone that's online. Yeah. Or so. Yeah. So do we know, are people online again? Or should we just start anyway? All right. So don't forget, so the plan right now is to do, I have a set of slides, but they're not super interesting. There's like 2 slides, is to do another example / tutorial. You're more than welcome to run it yourself. This is the first time I've done this in a large group, so we'll see how it goes. So in this case, what we're going to run is, so Sean thought it would be interesting to deploy some sort of higher level things that like maybe a scientist would actually want to run. And of course, something very interesting to everybody these days is LLMs. And there's the tool called Llama that many of you probably have at least played with. And if you haven't, just know that what it is a tool that you can deploy your own LLM and you can chat with it and interact with it. That's the basics. You can also write applications that interact with them and things like that. That's more advanced. We're not going to get too far into that today, but if based on what you see today, you can actually, if you know how to build more things on top of these LLMs, you can do that. So what I'm going to show for the next, I scheduled for 2 hours because this one might take a bit of time because there's a lot of, A, it just takes a little time to deploy the slice, but B, there's a whole bunch of sort of intermediate steps, which are new things that we're going to learn as we execute them. So it could take a little while to get there. And yeah, so we'll deploy a slice. See here, sign up for the tutorial. Yeah, I guess here's the example. We'll run a Llama LLM on Fabric. There's a few different ways to interact with it. So you can kind of just log into the node and start typing on the CLI, like ask it questions. We can show that. There's ways to use an API via REST interface. You can use an API via like a Python tool, and then you can also access it remotely. So you can run in the LLM on a server, and then from another machine, you can access it and query it. And we'll show you 2 things. One is accessing it from like your laptop. So this is a kind of a tricky thing to do because, of course, we have the Bastion host in the way, so we can't have a server on the VM in Fabric, but there's some ways where you can create tunnels from your laptop to the server and then access it. And so I'm going to show you how to do that using SSH tunnels. I'm going to hint it at some of the people in the room that I really like Tailscale. That's my preferred way to do it, but it's a little bit more complicated to set up. SSH tunnels are kind of, I can teach you how to do that in 5 minutes. And then the other thing is the ability to access the LLM on one Fabric node from another Fabric node. And you can either create another slice to do this, or I think we're going to try to have you access each other's LLMs from your nodes, because I think that's also going to be possible. So this is the first time I've run this this tutorial, so we'll see how it goes. Should be exciting. So here's the picture. This is kind of what we want to do. We want to have forget this slide for a minute, but we're going to have a VM with a Llama running in it. You're going to be able to log into that VM and access it. That VM will also be on the FabNet network. So you'll be able to provide that service across FabNet. You'll also be able to access it from the management network via an SSH tunnel, as I was saying. But then we're also going to install inside of a Docker container, inside of the VM, something called Open Web UI, which is a tool that you can use to get like kind of the way you're familiar with interacting with LLMs. You have this sort of web-based tool that you can chat with. This is the web-based tool that can sit on the front end of an Llama LLM. So it can show you how to do that. And you'll be able to access it from your laptop. You'll be able to open your web browser, ask it questions, and it'll be running things on the VM. Yeah, so there's a few different things we're going to learn. We're going to learn about post-boot configuration. So there's going to be some tools when we launch this slice. Before we launch the slice, we're going to say, here's some things that I want you to execute after you're done booting. And it'll do that and it'll configure itself. We'll talk about that in a little bit. We're going to install and execute, or install and run Llama, as well as Open Web UI. Open Web UI will be in a Docker container. So we'll show you how to run Docker containers on Fabric. Show you how to query the Llama service directly. Show you how to query Open Web UI. from your laptop, requiring the tunnel from the Bastion host. And then as a bonus topic, you can start a second VM and try to access your LLM from it. And then you can start thinking about deploying sets of resources across Fabric that are interacting with each other. Yeah, so that's what we're going to try to do. All right, so let's get to it. Oh, the other thing I want to show you is the artifact manager, because all of this will be in the artifact manager. Okay. So step one here, just to kind of give you a tour of what's going on. If you go back, I think I'm still logged in. If you go back to just the straight portal, what you can do is you can go up here to experiments and click on this link that says artifact manager. When you click on artifact manager, you're going to get this list of all these artifacts, and you should be able to search the artifact manager for various artifacts. So if you wanted to, for example, learn about P4, you could type P4 and you're going to get a bunch of different artifacts, that various people have shared that'll show how to do P4. There's a Bluefield one, there's some DPU P4 example one. So if I click on this, what this takes me to is a little description of an artifact, tells me who built it. So these are the folks at University of South Carolina. You can see that 26 people have downloaded this since this has only been up for a month and a half or so. If you come over here and download, this is what you're going to end up downloading the artifact. It'll just give you a big tarball. You can get it on your laptop, uncompress it, see what's in it. What's in it is probably, it can be anything you want to put in it when you build these for yourself. But what's in it, most likely, because it's a Fabric user, is a Jupyter notebook, maybe some configuration files, some scripts, maybe some data, and some instructions on how to run it, right? So I just clicked on this Bluefield one to kind of show you. There's a bunch of them here. Whatever it is you're interested in, I don't know if you want to do, I don't know if education is an interesting thing to choose. Maybe not. If we click on education here. Anyway, you can look through these artifacts, find all sorts of interesting things. There's many dozens of them, and people add them all the time. If you have an interesting thing to use in a classroom or research, please make an artifact and share it. Other people are probably interested. Okay, so we'll go back here. And if you, well, it's the first one, but if you search for like Hawaii, you'll find it. So I made this artifact here, Fabric Tutorial, University of Hawaii, November 2025. Inside this artifact is the example Olama notebook that I'm talking about, along with a bunch of scripts and configuration and things like that. You click on it. Don't download the old one. I should probably delete them, just get the newest one. That was me trying to make it work. But you can see here it is. I'm going to show you like what you can do is just click on it and download it. You can see it's just going to save it to my downloads directory, which is a fine way to do it. You can see that it's a tarball. You can uncompress it on my laptop. But for most of you, you don't have all of the keys and tokens and everything set up on your laptop. So one way to do this is you download to your laptop, and then you can go into Jupyter Lab or Jupyter Notebooks and upload it. Another way, which is maybe interesting, is we wrote this little tool. So if you're in the Start Here notebook inside of your Jupyter Lab or Jupyter Hub, if you come down here to this Explore Fabric Artifacts, there's a Jupyter notebook there. You can read about it if you like, but if you just run this, one of our developers wrote a little GUI that runs inside of the Jupyter notebook. And this GUI, you can actually do the same thing. So if I wanted to search for like P4, I think maybe it has to be longer than, maybe it did work. Just as a search. You can see, yeah, you can see like all of the artifacts that people have written about P4. You can see like this particular one is some sort of DDoS detection, SDX, something from somewhere. You can see there's different versions of it. And you can hit this button that says download, and it'll just download it to your Jupyter container and uncompress it and use it. So what you're gonna wanna do, like one, you can just download lots of these if you want. If you find anything interesting, just hit the download button, you'll have it and you can just go play with it. But if you go here and if you do Hawaii, you'll see that this is the one that I created. Make sure you're selected the newest one. And if you just hit this download button, what will happen is it's going to go get it, it's going to download it, and it's going to put it in my main folder here. So you can see that this was created right here. University of Hawaii Fabric tutorial. If you double click on that, it's just a folder. If you get more than one version, you'll have more than one folder there. If you just dig into it, eventually you'll find the folder that has all the things in it. So in this case, there's a notebook called Olama. There's another folder called Olama Tools and another folder called Node Tools. This Node Tools sort of technique is something that I do a lot. So let's open up this Olama notebook. You can see this is deploying GPU accelerated Olama LLM server on Fabric. You can see it has a lot of explanation of what it does. There's lots of clickable links here. So if you wanted to learn about the different Fabric calls that we're making, you can just click through and you can, like, I don't know, if you want to see about slices, here's the code that about slices and that kind of thing. In this Node Tools folder, you can see there's some shell scripts in here. So one of them is like enable Docker, another is host tune. Inside Docker, the Docker folder is a configuration file for Docker that actually allows this particular Docker and LLM work if you're on an IPv6 site. So there's a bunch of configuration in here. Like you can just look in here. This is the Docker daemon.json file. Oh, it opens it in weird JSON way. But I think there's a way to, like, if I right click, I think open with editor. Yeah, that's better. It's just a little file. If you put this in here, Docker will work with IPv6 better. So what you can do, like the trick here, the key to learn here is if I go back to here, inside these folders, this Node Tools and Olama Tools are just little configuration files. Like you can see this Olama has a Docker compose file in it and so forth. And what we're gonna do is we're gonna launch Fabric slices, and then we're gonna use some fablib calls to copy these folders into the VMs. Then we're gonna use execute commands to just execute the configurations. And this is a way to automate the configuration of your VMs. And this is sort of like the way we tend to do it. Okay, so if I go down here, feel free to read all of this. It's pretty elaborate, but it's there. Well, I'll just execute the execution cells and then tell you about them as I go along. So this is, you've seen this a bunch of times. It just, starts the fablib manager and prints off the config file. Hopefully everything's happy. Here's a pretty typical model we have. There'll be a cell near the top of the notebook that just has some configuration. So this is like, what is the name of the slice that I want? What is the name of the node that I want? What kind of like hardware I want, that kind of thing. Here's a few more we have here. So this is actually saying, how many cores and RAMs and disks do I want for this particular site? Because we're going to choose a slightly bigger VM than we did the first time. In this case, I have this sites avoid list. So in this case, I know there's a couple things I knew before I came here. One, I know that the networked attack is actually broken right now. So you don't want to use the attack site right now. But so if you put in this avoid list here, the attack, when we do the random choices, we won't choose the attack site. And then I also know that the Sienna site is actually in transit between Ottawa and St. Louis right now. So it's actually down. So you don't want to try to choose the Sienna site right now. So these are just some configuration. This is a pretty standard model that we have, is to like put configuration at the top. Here, and I'll run this while I'm talking. This is a cell that is going to get a random site, but that random site is going to have at least one GPU on a particular host that you're going to choose. So if you all run this at the same time, it could be that you happen to hit the same node, but if you run it and then execute it, then someone else runs this to get a different site, you won't conflict. It should do a pretty good job of making sure everyone gets a GPU, provided there's enough there. But there is a race condition. So go fast, I guess. I don't know. If you run this by yourself, it would work fine though. But you can see here, if you look, I mentioned in the previous example that there was these tools like list host here, and list host was one of the ones that would show you like all the hosts that we have in the whole system. We did list sites the first time, but list host is similar. You can see I'm adding a bunch of fields to that, including sites to avoid and a filter function, which I'm passing in this filter function that's right here. And this is it's a Python technique that people use. What this is it's a lambda function, but we're calling it filter function. So it's passing it in, and if you look carefully here, what it's going to do is it's going to basically pick a site that has at least the amount of RAM and core and disks that you're asking for, as well as a GPU. Actually, it's going to pull the GPU out later, but so it's going to pick a site that has at least the RAM and core and disk you have, and then down here, it's going to go through it's going to get a random choice, and it's going to like go through and pull out the GPU or pull out a specific host that it's going to want you to use that it has at least one GPU. So you can see, for me, it chose star W2, and there's at least 2 RTX 6000s there. So when I create my slice, I'm going to specifically say I want to have my site at Starlight. I want it to be on Starlight W2. I want to have an RTX 6000. And in theory, there should be one, unless you guys just grabbed it before, in between me searching for it and me allocating it. So if you want to look, this is kind of a complicated little script here, but you can look through it and figure out what we're doing, and you can model that to find the types of resources that you want. So I'm gonna go ahead and hit play here. Hopefully you guys didn't steal my node, and I will get this slice running at Starlight. So what this is doing, so you can look, we've seen this before too. So we have, we're gonna create a new slice with that particular slice name. We're gonna add an L3 network. People remember what that means? No? So this is, you can guess. So this is going to create a network, a layer 3 network. So this is going to be on our FabNet network, and it's going to be it's going to have the name that we named it above. Here we're going to, I have to scroll over and make this go away, and you can maybe see more of the screen. Okay. So then we're going to add a node, and this is just the one node in this case. We're going to name it Olama node. We're going to have the number of cores we asked for at the top, the amount of RAM, the host that we picked. So this should be Starlight W2 in my case, and yours would be something else. The disks, the picked site, which is Starlight. And here I'm going to specify the image as Ubuntu 22, as opposed to the default Docker one or Rocky one. Mostly that's because the NVIDIA tools for the GPU are easier to install on Ubuntu, and Kamal and them wrote the scripts to do it, so I didn't have to learn how to do it myself. I just copied them. Then we're going to come in here, and we're going to say add component. So we're specifying the model of the component we want, and so it's the GPU I specified up there, which is an RTX 6000. And we're going to name it GPU1 because we just have to pick a unique name for this node, and that works. Then we're going to come in here and we're going to add a component to our Olama node and get the interface off of it. And this particular component, somewhere at the top, we specified it as being a basic NIC because all we really want is basic connectivity to FabNet. Set it to auto. It'll auto-generate the IP address based on the subnet and gateway that is given to that particular FabNet network. We add the interface. Then we get to this a new thing that you guys haven't seen yet. So here we're going to say node add post-boot upload directory. So what this is going to do, let me open this up. You can see what this is going to do is after the node boots, it's going to upload the directory Alama tools to the root directory. So that folder over there called Alama tools is going to be copied to the VM, but only after it boots, right? And then the same thing with the node tools. And then here we're going to run a script. There's a language where we can actually refer to the image that is in the that we used for the what is this, the VM, and we're going to pass that to here. So if we looked at that enable Docker script, it actually says like we're going to install and enable Docker. If you're using this image, here's the script. If you're using this other image, here's another script, and so forth. And here, so we're just going to say enable Docker, and this is the image I'm using. Enable some dependencies, that's the image I'm using. If you want, you can dig through the scripts and see they're just shell scripts that are installing a bunch of stuff, right? So this is an interesting way to do this, right? So that you have your folders, you upload them, you execute something, right? And while we're waiting, our node is starting to boot. It should get pretty close to done. What we're gonna find here, when this finally boots, so we have this one Alama node here, one network. When it finally boots up, we'll see the post-boot phase happen. And I know, and I was kind of talking to the people in the room over lunch today, that one of the things that's going to happen is it's going to try to install a bunch of NVIDIA tools. And because of some IPv6, IPv4 translation, it's actually going to take quite a while to do it, like several minutes. So while it's happening, we might actually log into the nodes and see what's going on. Is everyone trying this so far? Okay, cool. So we'll see. This is kind of a little bit of an experiment. I've never actually tried to install this while at the same time as a bunch of other people were doing it. And I know because of the way our NAT64 DNX64 setup works, there is a bottleneck on the bandwidth. So we might hit some of that. And we'll see here. All right. But once that boots, we'll be able to log into it and we'll be able to kind of poke around inside the VM and kind of see what it's doing while it's uploading stuff. Yeah. Okay, so you see my nodes and network are active. Give it another 20 seconds to query again, and we'll see that the configuring should be stable okay. And then we'll also see that the post-boot stuff will start running. Anybody else is active? Hopefully I was ahead of everyone. Oh yeah, I'm good, yeah. So it's stable okay. We have our node here. You can see the post-boot config threads are running. If you have a whole bunch of nodes and it does all of them, it'll actually do them in threads. So it'll do them in parallel, which is pretty good. I think it'll do 16 or 32 at a time. Doing them serial would take too long, depending on what you're doing. So while this is, grab some more space here. While this is booting, I'm going to grab my SSH command here and log in. I might log in twice just so I have two terminals if I want. You can see if I do list, you can see that we have in here our node tools and our Llama tools. I think, can I type HTOP? Yeah. We should be able to see things start to run in a minute. You can see, so dpackage was running. So it's basically doing a apt-get install of something. And it'll do this for quite a while. Yeah, you can see configuration is happening, apt-get is happening, and so forth. Yeah, so now we sit for 10 minutes. Feel free to log into your node and play with it and see what's going on. Any questions? No?
Do you have the status page?
There is, if you go to the main portal and you go to resources and you go to those resources overview, this is the main status. The tax link is broken in ways that is not on this. And I know for a fact the Sienna site, if you were to let's see if I can explain this. It's not up here. If I go to, if you do a list sites, it'll say it's in maintenance. So it should really avoid it anyway, because it shouldn't be getting random sites if the site's in maintenance. It's one of the checks that it has. But I like to be explicit. So also, just because you asked the question and we have plenty of time, I'll show you something interesting here. If you go in here and you go to your fabric config, right? In the fabric RC file, you can have a global avoid list here, which this is actually written incorrectly. That was automatically configured for me. It's not right. It should look like this. But you can basically say avoid a bunch of sites just all the time for me, like this. And I like to avoid EDC and EduKY because those are kind of the educational ones. They just don't have as many of the resources. So I tend to just put this in here. So you look in this config, there's lots of little tricks like this if you want. You don't need to use that though, but it's just a kind of a tip. Everyone made progress? Yeah.
Like the limits of this, because I know in like the previous hour you were talking about there was a class that had like 1,000 slices. Can you do 1,000 slices of picking a GPU?
1,000 slices that have GPUs?
Yeah.
There are not 1,000 GPUs. So when you get one of these PCI devices, you get exclusive use of that PCI device. So if it's a GPU or an FPGA or a dedicated SmartNIC, you get the whole thing via PCI pass-through, and you can do whatever you want to with it. The only reason we don't really care too much about these networks that we're using is because this is a tutorial setting. We're using the SRLV virtual function basic NICs, and there's effectively infinite of them. Like there's so many that we won't use them all. But in terms of like the real dedicated network cards, there's definitely a limit of how many there are, and you get exclusive use of the one that you have at any given time. So if you wanted to create, there would be a limit, and it would be the number of available GPUs. But also, if your project has access to GPUs and you are consistently using them all, we're probably going to ask you what you're doing. Not in a bad way. If you're doing something useful and interesting, that's great, but we just want to make sure that's happening. Both because if you're doing something interesting, we want to be able to brag about it so that the NSF keeps funding us. But if you're not doing something interesting, we want to make sure you're not in everyone else's way, right? But yeah, it's kind of what I was talking about earlier. We don't really have quotas or controls on how much the projects use. What we have is controls on what types of things projects can use. So if you're able to use GPUs, then you could use all the GPUs if you wanted to. But if you do, we'll notice. Yeah, that's a good question. I do hope this works sometime soon. There is another step here that's going to take a little while too, so I hope we get through that. I do have a pre-baked version in case this goes wrong, but I think there might be time to. I think we'll have time. Has everyone used Ollama before? Has anyone used it? No? First time? Yeah, okay, cool. So you have a little bit of experience with it. Yeah. Also interesting with this, you can get more than one GPU. So we've actually run like some of the hosts that we have, I think the host that has the most GPUs in one host has 3 GPUs. So you can tailor that query, and you can say, give me a host that has 3 or more GPUs, and it'll give you a list of all of them that have that available. And if you used all 3 of them, and you can run Ollama using all 3 of them, and you can basically get 48 gigs times 3 of memory that you can run your Ollama on. And that actually runs pretty big models pretty well. So. Yeah. I think this is just kind of working, so I'm gonna just let it go. I don't like to be silent. online doing all right? I guess there's chat here. I don't want to like show everyone's chat though. Is anyone monitoring the chat? Are people online doing all right? But like I said, what this is doing, if we wanted to dig into it, since we have plenty of time, I guess. There's another trick that a Jupyter Hub trick. If you right click on any of these tabs and you say, oops, I didn't select it, I guess. Yeah, if I right click on it and say show file in browser, it'll take my files here and it'll move that to the file that this file is, or the folder this file is in, right? So I just wanted to go find the scripts. So all I do is like right click, show file in browser, and then you're there. So then what we could look at in here, like Llama tools. Actually, the interesting one is more, oops, I did that wrong. The node tools, you can see that like, you know, what enabled Docker does. You know, this is a script and it has like, if your image is this script, then you know, here's how you install Docker. If you wanted to, you can like run. You can create these big sophisticated scripts, put them in a folder, ship them up and run them. And then I know there's one in here. It's a dependencies. I'll have to see. One of these installs. Yeah, this one's installing all the sort of NVIDIA related drivers and things. And this is the one that I know has trouble with IPv6 and v4 and has to go through the little translator that slows it down. But there's just a script that basically installs all the NVIDIA CUDA things. Feel free to copy it. Oh, okay, you see, like, so my node is done. You can see that it took 867 seconds, so a little bit of time. I don't know, to have a machine running in Chicago doing all this stuff, that seems actually not too bad in the whole grand scheme of things. So next, we're just going to pick the model we want. Kamal, who wrote some of the original pieces of this, chose DeepSeek, whatever version that is. You can choose a different one if you like. You can even change it by hand later. This is just to get it going. You have a reconnect to the existing slice. So this is going to get the new slice by its name and then get the node by the name, just to make sure that we have the latest objects. And then this one also takes a little bit of time. So this, if you go to, actually, I'm going to hit run because I know this takes a long time. But if you go to, this also prints out kind of poorly. Like, I think if you were to do this for yourself, you wouldn't actually have it print to the screen. You would have it like save it to a file and you can check it later. But for the purposes of demonstration, it's nice to have something moving around. You can see it's 2.5%, 2.6. When that gets to 100, it's done. You can see how fast it's going, or rather how slow it's going. Just for to show what this is doing, this is actually installing Llama using this command. And if you go to, just pick a new browser window, and if I go to llama.com, is it .com? I think it's .com, right? So Llama is where this tool comes from. If you go to the download, and you go to Linux, it basically says that's what you type to install this, right? So it's really not that hard. All we did was take that and we put it in this node.execute and it's doing it, right? That's as hard as it is to install Llama. Because in the previous step, we installed all the NVIDIA tools. When this is done, it'll know about the NVIDIA, the GPU, and it'll be using that GPU. To what I was saying earlier, if you had your VM have more than one GPU, it would know about all the GPUs and it would just use all the GPUs, right? I think you can actually pass parameters to say don't use all the GPUs if you have lots of them, but I don't know why you do that. Not on this machine anyway. So anyway, we're waiting. We can see we're at 7%. I wish I knew how to make this print less crazy, but that's what it's doing. If I was doing this for a non-demonstrative demonstration purpose, I would probably just, redirect that to a file and then look at it or something. But for this purpose, this is fine. Yeah. All right. How many are you this far yet? Did anyone get an IPv4 site? I bet yours is going way faster. If I remember off the top of my head, I think it's Tokyo, San Diego, Florida International, and there's one more. I don't remember what the other one is. Amsterdam. That one's IPv4? Oh, that's just, okay. Yeah, that's Amsterdam. That's at the University of Amsterdam. Yeah. Any other questions? Feels like it's going slower now. You guys all caught up to me. It'll get there. You can. I probably should have done that for my piece of it. But the way to do it is you can, like, you saw how we do like the random sites. So the random sites like queries the system for which sites are active and then gets a list and then just randomly picks from them. So if you know, like if you have 4 or 5 sites and you just randomly want one of those 4 or 5, just write that list, randomly pick from it. All of this stuff that FabLib is doing is really just stuff that we realized we were writing the same code in our examples over and over again. So we just like put it in the library so that it's ease of use kind of stuff. The get random sites is one of them. And also the get random site is like, I would say for most experiments, you probably want a specific site, but that is a terrible idea if you're going to do a tutorial with a bunch of people, because then if you make the example, say everyone's using Los Angeles, right? Then everyone uses Los Angeles and then it doesn't work very well. So a lot of this random stuff was really put in there so that we could teach groups of people how to do it without them using the same sites. I'm sure teaching it in a large classroom is probably also needs the random stuff. There's also, if you kind of think back to the map, the ring in the middle, the 1.2 terabit ring, if you have nodes that are on that ring, they tend to have better connectivity to each other because you're less likely to be competing with other users. Basically on that ring, you're never competing because those are never full. They're occasionally, we've seen it go over a gigabit, but I've never seen it, or sorry, over a terabit. It's even hard to say that word. It's hard to say a terabit. What's that? Yeah, yeah. It's hard to say terabit network. It doesn't make sense to me. Yeah, there are a few sites that don't have dedicated links. I think Georgia Tech, and there's one other one. SRI is dedicated, but it's only 10 gig. And then some of the ones that like Tokyo is also slow. The Trans-Pacific link is not over provisioned and it's shared. The ones to Europe, I think, are over provisioned. So it's shared, but it's never really maxed out. Sure.
In terms of managing all the sites, how is that done? Like, this is kind of not.
Yeah, honestly, but we have a bunch of people who are all assigned various parts of it, and they're good at what they do. That's so.
Are they just distributed? Like,
No,
I mean, you said they're all the sites are OpenStack. And so
they're all controlled by us. So yeah, so we have there's basically two staff members. So Mert, who's a guy that works at RENCI, and Assam, who works at University of Kentucky, and they work together really well. They're kind of like the systems people. So like anything that has to do with the OpenStack and the compute nodes and that kind of stuff, they take care of. They have all sorts of system administrator tools set up to warn them about all sorts of stuff, and they just take care of it. We have another guy named Tom Lehman, who is the wide area network. Really, he knows a lot about it, so he knows how to like set up all these links between all these campuses. He knows all the people, knows how to monitor it all. So when he finds something, he tells us about it and digs in there and debugs it. Like debugging layer 2 and lower things is really hard, because like there's no such thing as like a ping that shows you how far it goes, right? So it's just a bunch of people that have been doing this for a long time and know what they're doing. That's really what it is.
Yeah, so because there's two people taking care of it all the sites are as homogeneous as.
Yeah. They're all when we do updates and stuff, there's a lot of Ansible and involved, so they kind of just say go and things update. There's, like I said, I think there's 3 different types of sites, but of course we built this during COVID and supply chain issues, so we weren't actually able to get the same model of a lot of things. So there's some of the sites that are all special, and they know which ones are which. Yeah, the networks are kind of the interesting part too, especially the management networks, because every site, especially at the universities, are all slightly different in the way they have policy, and how their firewalls work are slightly different. I'm at 14%. I think it really did go slow, so this is gonna take a little while. Anyone higher than 14%? Uh-oh, you guys are gonna beat me. I do have a pre-baked one I can pull out of the oven if I want, but I think I'll let this go if I can. Yeah, you're gonna have to ask me more questions if it's gonna take this long. We got at least 10 more minutes. I could go a little further to see what's going to happen. Yeah, so basically this is trying to install Olama. It's taking a little while to pull everything down, to download everything. We get down here and it needs to like configure Olama. So what this is gonna do is it's gonna put something in the system D. It's going to basically tell it to bind to all of your ports rather than just your local host. What that'll allow it to do is to receive, be a service on the FABNet network. So you can access it from the other side of FABNet. And then this will kind of put that file in the right place. And then of course this reloads it all so that those updates will go into effect. Configures the firewall. So this port of 11434, that's the port that Olama serves on. So typically when you use Olama, probably what you did on your laptop or whatever, it's going to present itself on localhost 11434, and you're going to connect to it that way. Once we get to the open web UI piece, we're going to tell it go to localhost 11434, and open web UI will use that interface for you. Then the cool part is the next parts, because then I should be able to log in and show you stuff working. Hopefully this is this is going to take a while. We got time. We're not in a hurry, I don't think. Is this interesting now? People, what question are you going to ask Olama? You can see, if you scroll down, you can see the questions I have it pre-done for. I can tell you They are terrible, terrible jokes. Terrible jokes. I was just trying to be something like mildly interesting, but also inoffensive. So basically, it always asks you're asking it to tell you a joke about computer networks. Olama is really bad at, or I guess DeepSeek is really bad at telling jokes about computer networks. Let's see what it's doing here. Yeah, that'll work too. I want it to be like mildly computer related, so what can I ask it? So while we're waiting for this, what are you thinking about? What are you thinking about doing with this Olama instance when you get it up?
Do something interesting.
Okay.
Further down.
Oh, did you get it already installed?
Yeah.
Faster than me. Go ahead.
So what could you do with the Olama once you got it up? You can do some embedding.
You could, I mean, yeah.
We've been trying, so I've kind of hinted earlier that or at lunch, of trying to, we have some tools we're in the process of building, and I've seen some like prototype demos of them that work pretty well, that allow, this is mostly for the people that weren't at lunch, that allow, they have an MCP server that connects to the Fabric, REST APIs. The primary one we have working is one that lets you query the things that have been happening. So like what slices were created, when they were created, who created them, what projects, how long they existed, what resources they used, that kind of thing. So we have an MCP server that provides that information, and we can hook it up to an LLM. And so we can do queries like, how popular are GPUs on this particular site, or which projects are using the most, FPGAs or things like this. Hopefully we can use that to like kind of figure out what our users are doing so we can brag about them. The interesting thing though is we tried getting Olama to work with the MCP server. So we had it connected to the OpenAI like cloud system, and it works pretty well. We also connected it to Olama services. And one thing we found is that a bunch of the models that you can get from Olama don't allow to connect to applications. And the ones you can find that will work, they didn't work as well as the big ones. And I don't know if that's because the big ones are better, or the big ones are bigger or faster. I just don't know. But we're trying to like work and figure out which ones work best. I know with that embedded sort of AI chatbot we have in the portal, they spent a lot of time trying different models as the back end to that, and they settled on something. I don't remember which one they did, but I know that it varies quite a bit.
The model on the back, or you
It's
Wait, for the chatbot on the portal, I think they're using one of the ones and we're paying for it. Yeah, I think they tried to use a self-hosted one, and it just didn't work as well as. I don't know. Is that your experience too? Yeah. So we're. You guys are taking all my bandwidth.
the inference models
Does that work better? Yeah.
I think it does than Olama. I think Olama is like easy.
Yeah.
We'll try that. We're trying all sorts of things these days.
In a tutorial, they use field on that. So
We could if we wanted to. I'm gonna see if I can do this. Instead of us wasting that much time. On this pre-baked one. Here's my pre-baked one. I'll have to like
Load some of the.
variables.
Yeah, it's like almost a 3x speed.
That's what we're gonna see. So this is my pre-baked one. I'm gonna try to.
Restart it. So assume that we got past, we installed the Llama model here. Down here, I already ran this, but it, like I said, it sets it up so that it'll bind to all the ports or all the NICs instead of just the local host. You restart everything. You can see it becomes active and it prints off a bunch of things. We come down here, we can allow the firewall to work for the external ports. And here, this one is interesting. And what I can do is actually log in. Actually, I need to log in. I need to do, grab this. Yeah, here. And then if I were to log in and log out of these two, I'll log into my pre-baked ones and I can kind of show you how this works. So now you can see what this is going to do. This is saying Llama pull, and then it says the model, right? So here, if I do Llama, I'm just going to say Llama, and then you can see a bunch of commands you can have. One you can do is Llama list.
And you can see that DeepSeek was already pulled. I wanted to just to show you one working. If I do models, I'll pick like a small one. Here's Gemma. I'll pick like the.
I don't want to pick one too big if it takes too long. But let's say Llama pull, and then whatever model you want, and then it just goes out and pulls it from the system. And you can see right here, what this did is it just pulled the LM model that we had configured above, which in this case was DeepSeek something. But now if you do a Llama list again, you can see that we have both this Gemma one as well as the DeepSeek one that we had done previously. So all of these commands that we have over here, you can just log in and type them if you want. But this is just kind of a way to script them up. So you can say Llama execute or Llama node execute, and it'll just do it. Sometimes it prints a little wonky like this, but really wonky. We'll get there. Oop. Okay. The next thing, which you can do now, is you can like use this. Too far. Yeah, there it is. Okay. What you can do now is you can, well, in this case, I'm just going to test it. I hope I have a Llama node here. Okay, yeah, so I have to do this. Because I ran this earlier, I have to say like, I'm going to clear cell output. Okay, that's good. So that one's gone, just so we don't have to look at that one. But because I ran this earlier, yeah, this is the one I have to do. I need to get back my like query it, right? So now I have my like Python object is reset. I wouldn't have had to do that if I was in the same notebook. But here, so now my Llama node variable is reset. So I should be able to run here. This is saying Llama node execute. And this is just a test to see if the REST interface works. And you can see, okay, it gave me back some status that says, yes, I have DeepSeek running and there's Gemma involved and so forth. Then what we can do is test it with an actual query. So this is going to run a Llama node execute test query where this is the query and it's just a curl call to a REST call, which is going to ask, tell me a joke about computer networks. And then it'll if it works, it'll like respond with the answer. What is that? So it's like, I didn't set that somewhere up there above. This is the best thing about Jupyter notebooks is you can cheat like this. Should work. So now it actually sent that query, but if you look at the way we're doing this right now, we're actually SSHing to the node and then calling on the command line of the node. We're sending that query, and you can see it actually returned some jokes, but it actually returned like its whole big, like the way it's reasoning and everything, which is kind of useful, but like, where's the joke in there? This is why it's like hard to like do it this way. I don't like how it does this. Here you go. Why did the computer network trip on its own power strip? Because it had too many something trying to plug it in. I don't know. That's something. What is that even? That's so bad. What's that? That's probably, yeah. I wonder. It's interesting. Yeah. Here, yeah. Huh. That is an interesting thought.
So if you change it to the Gemma, what do you install?
Do you have to say? Let me try that. It might take a bit extra because it'll probably have to like load Gemma from. Yeah, it's a small one. Let's see what it does. Yeah. The other thing you can do while this is happening, you can do. This is a tool where you can actually see like how your GPU is working. So you can type like, often I do it like watch. Right. Oops, I didn't spell that right. So you can kind of see like how much memory it's using. Not very much, obviously, because that's a small model, right? Okay, since we're playing around, we have time, I guess. Let me go back here. Let's pick a bigger one of these. Yes. Because it needed some space. Right? Needed some space. It's so bad. Okay, let me do this real quick just to show you it. Yeah. So if I did here, is this my? Okay, so let's pick a slightly bigger of that. That might take a minute to do. As that's pulling, we can scroll down. So yeah, so this shows you a way you're usually SSHing via the FabLib executable to the VM, and then you're just manually saying curl this. You could, the exact same thing would work if on the command line you type curl that and type that all out. It would do the same thing. But there's some other ways you can do this, right? Okay, so one of the other things we have here is, oh, come on. Go away. I want to share that still. I don't want to stop sharing that. Okay. Actually, this other one's almost done. I want to ask it. Let's see. The interesting thing here. will be this. Yeah, let's let this finish and then I'll run that again. And what we should see when we run it is that it'll reload that bigger model and we'll see it using more memory or something probably. As soon as it does it. We do have plenty of time, I think. So. Is any of yours finished? Are you this far? Are you still waiting for it to load everything?
OpenStack, can you save, like, once this was installed, could you snapshot this image?
We haven't.
Enabled that? Part of the trick is that like if you do that and everyone does it, like that's a lot of different custom VMs and everyone's going to save them all the time. How do we allocate space, get rid of people's things, stuff like that? That's one thing. The other thing is like a lot of times you want to save it. When you bring it back, you might not want it on the same OpenStack installation. We have 30 something of them. How do we like synchronize your image across all of them? So we kind of, yeah, we don't have any feature like that. Some people would definitely like that, I think. I don't know. Is that something you think would be very, very necessary?
So I guess if you're looking for like domain, like if you're gonna spin up a bunch of domain service applications or something like that, you might wanna, yeah, be able to snapshot the images just to make it faster to bring them up.
Yeah.
For
It would be a good thing to have. We don't. It is actually kind of
trickier than you would think at first.
No, we don't synchronize images across JetStream. So
yeah,
like each region has its own repository. So
I think part of it is my
thought about a lot of it is the way I tend to use all this is I create everything in Docker containers, and then my configuration is basically install Docker, load container, done, right? So it's kind of the same thing, but then I can control my own images because they're the Docker images and put them in Docker Hub or wherever you want. Not everyone agrees with that, I guess, but yeah.
So I guess like your self-storage might have a cache of those Docker images for.
Yeah, and you could put those.
Yeah, if you wanted to, you could even put your images in there, and then your thing is like, okay, boot up an image, mount Ceph, install Docker, boot that image right there, right? So that's probably a good mechanism. So let me run this again. So this is, but I'm going to change it to the bigger yellow one. I think what we'll see. Oops, it's not right. I think what we'll see is if we watch up here, we should see how it went down to 0 because it's not being used. It should be much bigger than it was before, but it should take a minute to, because now it's got to reload that one. You can see it's 1 megabyte 18, so it says burning this. And then at some point we'll see it using things. Yeah. So you can use these little NVIDIA tools to kind of see what's going on with your you kind of see how big a thing you can do. It looks like there's 24 gigs here, and we're only using 10 over there. And it looks like it stopped. So we can probably do one twice the size, right?
Router.
As it says, not you, it's my son.
They're so bad. All right. All right. So here we have is another way to do this. So, and this is Kamal's favorite way to do it is like we actually have this query.python file that we put in Olama tools. So I can kind of open it here and show you what it is. It's not that complicated. It's just sort of using JSON, but inside a Python file. So if you wanted to do it from here, and it has this like whole way to like, you know, tell the prompt you want to send and so forth. So you can actually specify like prompts and a bunch of other things that you wanted in this little request API. And you can see how it sends this request with the payload and the model and the stream and so forth. So it's not that different, but it's just using code to do it rather than like a big script that you ran on your thing. So I can do it and it'll say, you can see here, it asks the same question. Whoops. Tell me a joke about computer networks. You can see how many different ones we get. Yeah. But what this is doing, if you look carefully, come on, go back over there. This is, why did the network administrator break up with the router? Because they said it was too flaky and kept dropping connections. It's interesting that the Gemma one really likes jokes about breaking up. I don't know why. We'll see. All right. It's hard to have, actually, that's what I'm gonna do. I'm gonna put this down here and this over here. Now we can have both of these on the same screen probably. Yeah. Okay. Okay, so we have another way. So in this case, what we're gonna do, you can see that what we're gonna do is enable access to Llama from across Fabric. So if any of you have yours like up and running? No? One person? Okay, so we can do this. Have you run this command yet? The one to get your IP address? So this is my IP address right here on FabNet, right? So what you should be able to do is if you queried my model, you should be able to query my model, and I could probably query yours. What IP address do you have? You said 10.144.52? That 5.2? Yeah, okay. So in theory, I'm just gonna kind of hack this together a bit, but I should be able to go back up here. Instead of localhost, if I type this, and now I'm probably querying your model, assuming it's up. And so if you notice here, what this is just us using a different host, but it's going across the Fabric network, not across the internet, right? Assuming it works. Let's find out. So if you wanted to write your service in a separate VM inside of your experiment, you could actually have your Llama over here, and you can have something that's querying it over here, and they could be different. They can be different services and clients. Is yours up and running? I mean, obviously this isn't died yet, so it's probably something's happening.
The video tools aren't saying anything's happening.
Oh, you know what it's doing a bit? Yeah, it's forcing yours to pull the model that I'm wanting to use. Yeah, it's whatever one I have set for default LLM, but I don't. Yeah, that's what it is. You're currently pulling the big Gemma model. Sorry for that. But anyway, that gives you kind of an idea of like what's possible here. So if you can kind of put these together and build them together. We should probably wait for that to happen. That's too bad. I should have done a smaller one. Yeah. It won't take, I don't know. We got a little bit of time. No one else is there?
You are?
Well, you sent a command to me to use resources. Oh.
But it is using this?
It's going up.
I think it's forcing you
to download the model I just asked for. Because I changed the default model, so you hadn't already downloaded that model. Okay, here, I got it. Oh, it says, uh-oh, connection match generated some sort of timeout. Maybe, I'm not sure why that didn't work. You got mine to answer your response though, right? Or no? Oh, sorry. I don't do that. I don't want it to break. I'm not sure what happened there. Okay. So here's another one. Let me clear this output. You can, of course, just, where'd my, I don't know. The screen's so small. I have a hard time with it. You can just type things at the command line. So of course you can just say like Olama, sorry, Olama run. This is the one I have loaded, right? So this is the one that I already have loaded. Let's do that one. Model, and then you can say, tell me a joke about networks. Right. And that's how you can do it at the command line. And if you come over here, you see it's now using 43% of my GPU. And then of course it says, why did the computer network break up with the router again? Because it said you're always routing around me. Hope that gave you a chuckle. Okay. Yeah.
That with long installs, if they need to walk away or if it disconnects for whatever reason, are they able to pick up where they left off on the install?
On an install of something, if the command is like a Olama execute something, if it disconnects, it's kind of like your SSH den and you got disconnected. Now, what you could do is inside your olama.execute command, you could have it run in the background and then you could come back, but you'd have to do that yourself. Yeah.
Lettuce and tomato, apparently, like the DeepSeek.
Yeah. But the key is like one thing that you have to understand about how this FabLab thing is working, like when you submit a request to create slices, that happens kind of asynchronously. But when you're doing these like execute this or execute that or upload this or upload that, that's happening as an SSH command, as if you like typed SSH, run this command. So you'd have to keep it up and running.
The Jupyter, like
So okay,
yes. So it's I guess the socket's open on your Jupyter, and if you close out Jupyter, then it's disconnected, or because it's running, the Jupyter's running on your slice, it's still there even though you close the window.
It's really more of a Jupyter thing. I would say this. So one of the other things is before, say a couple of things here. One, this is Jupyter Hub running in the Kubernetes cluster that Fabric maintains. And if you are idle for a long enough time, it's not like minutes though, it's like hours. It will actually shut down your container just to save us from spending too much money. So that, what's that?
Executing on that. So like
if you think
command and it's still.
It does feel like it
cut you off like that. I would say that if that's something you're interested in, there's a couple other ways that I think are maybe preferred. So we actually have a Docker container that we've put together where you can run this Jupyter Lab in a Docker container on your laptop or wherever. That seems to stay persistent. In fact, if I'm running a Docker container on my laptop, I can actually like shut the laptop, go home, open it, and the Jupyter Hub will still have all its state. Where this won't do that. I'm not sure why that is.
Answer this person's question. They should pass like a no hub or a
yeah.
ampersand at the end of their command.
Yeah, I think that is the right answer
there. Somehow do it like asynchronously. Take care of that. Yeah. And also just keep in mind that this is all just a Python script, so you don't have to use Jupyter to do this, right? You can just use regular Python, right? Okay, so here we'll get to something more interesting. So the next thing we have here is this is a command here that I ran already that is actually going to do Docker compose up inside the Alama tools folder. And inside that Alama tools folder, if we look at, I think this is actually it. Let me make sure this is the right one though. It's the pre-baked one, okay. You can see there's a Docker compose here. And this Docker compose is open web UI with a bunch of things set up to work and connecting to localhost 1143. So if we run this will run a Docker container on this host that will connect to the Olama server that we just had. So if I look here, and let me close this out and type Docker PS, you can see I already ran this. It started 7 hours ago because I started this this morning in the hotel room just to make sure it was there. So this is my open web UI running on my same machine that is running the Olama, right? And because the way we configured this, it's actually connecting to the Olama at localhost 1143. So it's connecting to my Olama host, right? Okay, but the problem is now you have this open web UI service is the web UI, right? You're supposed to use a browser and connect to it and do things. But it's on a fabric node that's behind a bastion host, and you can't put services on the internet. So how do you get to it, right? That's the question. So we go back over here. We have another kind of slick little tool that helps you do this. I'm gonna clear cell output. We don't have to see that downloading. So that ran, we know that ran and it's up. So what we have here is something that's built into FabLib. So you can say FabLib create SSH tunnel config. And if you say override equals true, it'll override it. And what this is going to do, and this is when I ran it earlier, it creates a tarball and it puts it in home fabric work, fabric config, and then that file. So if I go over here and I go to hit my main to go back to my main work directory, I go into my fabric config directory, you can see that there's this tarball that was created 6 hours ago when I ran that the first time, right? So if you download that, you can download it. You just right click, hit download, and it'll copy it to your downloads folder. I already have it on my desktop, so I'm not gonna, I'll just download it, but I'll show you what I have over here. So if I go open a new window, this is a terminal window, which you can maybe read. Maybe I should do this. Is that better? So this is a terminal window on my laptop, not on the Jupyter Hub. And so if I go, I downloaded this earlier and I put it on my desktop just so I can remember to get rid of it. What's it called again? That fabric SSH something. Okay, so I just CD here and then list. You can see that tarball is there. I uncompressed it earlier as well. If I CD into here, you can see what it has in here. Basically, it downloaded the bastion key and the slice key that I was using for this purpose. And it also created an SSH config file there. And if you cat the SSH config file, you can see that it's telling it to use my bastion login ID, and when you go to the bastion, the bastion fabric -test.net and so forth. So what this is everything I need to be able to SSH through the bastion host, right? So I could do that using all of this. So you can now SSH from your laptop to your VM using these things. Works on Windows, works on Mac, works on Linux. It all just works. I go back here now, and you come down just a little bit further. It says, so this next window here actually spits out this command here. So what this is, let me make it just a little bit wider so you can see the whole thing online. So this is an SSH command that's actually going to build an SSH tunnel from your VM that's in Fabric to your laptop. And what it's going to say map 127.0.0.1 so localhost 8080 on your laptop, map it to 1.2 localhost 8080 in that VM, right? So since we know that the Open Web UI is listening on localhost 8080, what this will basically do is make the localhost on your laptop tunnel into the localhost on the VM on port 8080. And you can have this be different. So like if the 8080 on Open Web UI is here, you can have this be like whatever number you want, right? And you would just use that on your laptop. So when you do this, and it uses your slice key that you got from the tarball, uses the SSH config you got from the tarball, and then it uses the IP address that it got from the management plane. Happens to be IPv6 because I think this one's at Tokyo, if I remember right. So if I take this command, just copy it, go over here, I'm inside my SSH tunnel here. I do this, I should SSH into that machine, but the other thing that happened is it set up this tunnel between the two. So what I can do now is go over here and I can type, this is just a browser on my laptop, right? Localhost 8080, oops, 8080. And this is the Open Web UI. It's loading slowly. But it's the Open Web UI on my VM. You can see it's still running the Gemma command, and I can say, tell me a joke about type at this angle. Right. Oops, I don't know why it's a question. And it'll just do kind of like the normal thing you would think one of these would do. If I really wanted to, I could look. This is why did the router break up with the? It's all about breaking up. It couldn't see eye to eye. It was all one direction traffic and wanted to connect to everyone. So it's just another joke. You can also go over here and you can see these are the other models that I downloaded before. If you wanted to get another one, you could do like, I don't know, I think you can search for, I forget how you do this, but I know you can, like, if you want to download the models from here, you can like maybe pick one that we haven't already done. I don't know if it's this one. But go here, search for the model, and then it'll actually download it right now and load it. I think it's actually downloaded it. Did I do it right? I didn't do that right, did I? Oh, here, I have to click on pull. And now it's actually downloading it to my, if I went back over here, you would see if I typed llama list, you can see now I have, did I do it? Maybe it didn't do it. Did I already have that one or just did it? What's that? Okay. Another, let's get off. I don't know which one you guys like. This figure here is a llama, just regular llama, and copy that. I think you can do it. And then you say pull. That looks like it's actually thinking about pulling. Okay, that makes more sense. I think, yeah, that one went too fast last time. I think I already had it. But so anyway, this is just like a GUI interface to this llama running on Fabric. But the real thing to take away here is that with that SSH tunnel I'm able to put services on Fabric that you can consume from your laptop or elsewhere. But this isn't available on the internet, right? So this is sort of safe and secure, but you can still do it, right? If you want to do really fancy, go look into Tailscale. It's a much easier, slicker way to do this. But what am I looking at?
No, sorry. I was just thinking. I was just connecting to my mind about this isn't when this is only can be seen from other people on Fabric right now, or not, or this is like you're actually doing this privately, right?
So the Open Web UI can only be seen from my laptop because I have a tunnel. The actual Olama server that is running on my VM can be seen by any of you because you're on Fabric, but you can't see it from the internet. Right?
I was thinking about privacy, because you're basically running this kind of thing using the GPU, but you can put on personal information. Like if you want to do something specific about like your health or something like that, like if you want to use people's actual information with that and not have to serialize it if you're running sensitive information, like defense stuff like that, you can aesthetically it's a way you can use some of the stuff without it being accessed publicly. Is that right?
In general, I'd say yeah, it's probably Olama or any of these like self-hosted ones. The powers that be don't. Yeah.
On your own personal computer would be.
Yeah.
How?
Yeah.
So
I will add that Fabric, we have to say this a lot, is that if you're gonna do like actual private information, like if you work at a hospital or something like that, you can only use services that are like condoned with whatever policies that you have. And Fabric does not have any policy that it uses and is approved to be. So because of that, if you're going to use Fabric, we just kind of put it on you to say, like, if you think that the data you're putting on there is safe, then go for it. We're not going to approve. We're not going to say it's okay. If you get in trouble, it's on you, not us, right? Yeah.
You could maybe test Fabric to see if you could develop a system that could work for that, maybe.
Yeah.
Stand up the other infrastructure later for like a production one.
Yeah. We do have plenty of people that do like genomic things and stuff like that, and they just have fake data that they put on Fabric. All right. So yeah, that's for the most part what I have. I just really quick, I'll say advanced challenges to extend this work if you like. So like multi-client deployment. So what you could do is deploy like the Open Web UI on one VM and the Olama service on another. You could also write different sort of clients that write them in Python, write them in whatever that will access your Olama server and do interesting things. You could extend it to do MCPs or just whatever, right? So this is really dynamic. You can put it on Fabric and do it, right? So a challenge to do that. Distributed Open Web UI, that's what I just said, I guess. OpenSSH tunnel directly to the Olama API. So what we did is we created a tunnel that went to the Open Web UI, but you could just have a tunnel that goes direct to the Olama service, and then you could run something from your laptop that's querying that. It's a challenge you might want to try. And then, like I said, Tailscale is one of my favorite things. So adding the Tailscale, and then you won't have to have the SSH tunnel. It'll be sort of done for you. There's just some other challenges you can try. Hopefully some of you got this figured out. So it's 3 o'clock, so it's a kind of perfect timing for taking a short break and then having just kind of a wrap-up discussion about what you guys are interested in. Hopefully some of the people online will participate too. So should we take 10 minutes? Yeah. So back at like 3:12. What do you guys think of that? question about, hey, like, what do y'all find interesting so far? What are your thoughts? Like, what was unexpected, and maybe you think of, oh, I can do this or that with it. I'm also gonna try to take notes while we talk. So it might be hard to do all these things at one time. So if you guys talk more, that'd be awesome. But so I don't know. What do you guys think? What's your takeaway? And anyone online too, but I don't know how to. Maybe Sean can be the translator.
Yeah, I'm paying attention to see if they ask it in the chat, or I think they might be able to unmute and ask.
What happens if someone online unmutes?
I had a question about, so you mentioned like facility ports or
Facility ports, what we call it, yeah.
Yeah, did you want to just discuss that a little bit more? Because I know I'm interested in doing one for our HPC to hook into Fabric a little bit more effectively. Yeah. So we can better get at our Fabric node hosted here and then the rest of Fabric. But I guess how challenging is it if other folks wanted to hook up instruments or?
So the process is. There's usually a use case of some sort, like you want to do something. I always go back to the cryo microscope use case. That was one of the first ones we did. And they have this microscope. We can connect to them. The process is to express interest. And then we'll set up a meeting with probably the researcher that wants it done, or instructor, or what have you. Me, and then Tom Lehman, who is our like wide area network, provisioning guru, and then probably somebody on your IT staff. With you guys, it might even just be you, like somebody who knows like how all of your switches are linked together to what buildings, and in this case islands, I guess, that kind of stuff. And we'll just sit down and figure out like what you're trying to do. We can tell you from our side what most of these look like, and then we can kind of figure out how to get across your campus. You're fortunate because you have a site here, so it's much easier because you just have to get, usually it's a VLAN that you get from your instrument to the Fabric site that's, in this case, on your campus, which is much easier than trying to do one that's in another city. But even if it were in another city, we know how to do it. Like, for example, if you wanted to have one to connect to Guam, I'm sure you guys have, there's a way to do that, right? It's probably not campus centric, or maybe it is in this case, I don't know. But yeah, we would just work it out. Every one of these is a special case, but we just need Tom and his expertise to like figure it out. There's a lot of considerations off the top of my head. In a perfect world, you would have a dedicated 100 gig wavelength from the Fabric site here to whatever the device is. That usually costs money. That's usually probably overkill for a lot of things. But on the flip side, if you do like a shared layer 2 kind of thing, we'd have to be a little bit more careful about how much bandwidth we let go across it, because we've had problems in other places where our users just kind of like take out like a whole campus or something like that, because we have quite a bit of bandwidth, and if we aim it in your direction, you have to be able to consume it. If you can't, then you could have problems. So we have there are a handful of our links we have that are artificially slower than others, because it's been a problem when we use all of it, right? So that's something to consider. I don't know what else there is to that. I think we would just have to get in the room and talk, right? We have the real interesting thing, I think. So one of the first facility ports we did was when I was working a lot on the Chameleon project. So the facility port was actually to connect Fabric to Chameleon. And part of the benefit there was I designed most of the networking on Chameleon anyway. So because of that, like what you really want is somebody that so Fabric, we know how to like provision these connections to the facility port to the edge of Fabric. Whatever's on the other side, you also have to like maintain that somehow. And that could be just a dedicated VLAN that lands somewhere and just stays there forever. But it could be some dynamic thing. So like on Chameleon, for example, there's a whole bunch of, a pool of VLANs that users on Chameleon can allocate to their Chameleon projects. And then they can allocate on the Fabric side, and then they match, and then it works, right? So yeah, you'd have to think about, like if you're doing a telescope, how does the user use the telescope, and then how do they trade off and give it to the next person that needs to use it, and things like that, right? But every case is different. Yeah, so we should get all the right people in the right room. What is the use case that you were thinking for here?
So I was going to talk some more with some of our Institute for Astronomy folks. And see if there are some additional use cases for Fabric, but our infrastructures are sort of connected to like our Lustre storage system, to some shared storage with them. But I think if we did a facility where they would be able to access that through that.
Yeah, that's a pretty good one too. Like several of the supercomputing centers, just generally, like a good starting point is to have a way where somebody on Fabric can access the data transfer node at the compute center. So then what it allows you to do is just move data in and out of the compute center fast. And then once it's there, you just access the computer in the normal way, right? So that's a pretty standard way, because a lot of people don't really want these connections all the way in too deep into their systems. But yeah, so landing on one of your file systems would be probably a good idea. Also interesting is the other way is like kind of like what the Rutgers people do is they're pulling stuff off their microscope and they're processing the images on GPUs and Fabric. So I imagine telescopes have similar things that they do. I'm not sure exactly how it works.
There's been discussions that right now they're resource constrained on being able to process what they can process for the specific use cases that they're funded to do, but there's so much additional data that could be processed for other phenomena that they're interested in doing that, but just don't have the capacity.
Yeah, and I mean, obviously our Fabric sites aren't supercomputer sized, but they can do some interesting things, especially if it's like experimental and something that you just don't have funds to do otherwise, and you might be a little disruptive. There's another thing that a lot of the astronomers do. Like I know that when I've talked to the CMBS4 people in Chile, like one of the things they talk about is, and this is probably true here too, is that I might be a little bit wrong. So as an astronomer, like I'm by osmosis learned a lot of this, but they basically scan the night sky all night and they look for transients, so things that have changed since yesterday or whatever. And if they notice something, one of their goals is to tell everybody else around the world that is in the dark side of the earth at the moment, go look over there, something's happening. And so their problem is, how do you take all the data from the telescope, get it to a computing center, process it so you can find the transient, and then distribute that information to the right people, like in near real time, right? So it's both like getting the data, processing it, but also distributing the answer to all the people that have subscribed to it. I think Fabric can probably do something for that. I don't know if that's what they do here or not. Yeah.
So yes, they do so.
Like there was I think a demonstration of like the P4 like configuration for preventing like DDoS attack. That's an example I think of like taking the headers and then looking at being like, oh, we're gonna reject all the traffic from this.
That could be. I mean, yeah, I vaguely remember that. Was that one of the South Carolina people or no? Do you remember? I know.
It was a P4. It was a P4
Yeah.
one, but I was just interested in what other cybersecurity things like that people might be doing within Fabric.
Cybersecurity related ones. I know there's it's not really security. How do we get to, let me see. Where can I find that picture? There's at Illinois Institute of Technology, Nick Sultana has these two projects. One of them is called Crease, and the other is called Patchwork. And they're both fabric related. And one of them is basically looking, they call it, what's the term they call it? Remote attestation of packets. So they have inside their switches, they're able to like look at the packets that are coming in and deep packet inspection. And then inside the packets, they have some way of like attesting that the other switch actually sent it and it hasn't been like corrupted along the way. So that's one of the things they're doing. So they're looking into the into the packets, using a lot of P4 to do that. But that wasn't the one that you saw, but this is another one similar to that. The other thing he does is actually like a distributed debugger kind of thing for like how do you debug networks, like network topology. So you have you have the University of Hawaii network topology, whatever that means. It's like super complicated. No one knows about all of it. How could you look at all of that and find like problems with it? Like maybe it doesn't match your specification, or maybe something is maybe misconfigured in a way that's bad, right? So that's an interesting thing to do. Those are two that I know of. Those are the two I know of off the top of my head. There's some other people doing like anomaly detection, so they can like look at packets as they fly by, and if something weird changes, they can guess that someone did something, and it could be like a bad actor. And then, like we were talking at lunch, a lot of people would like to use Fabric to do some of these like red team, blue team kind of stuff. I don't think anyone's actually done it though. A lot of people get excited about it and then don't follow through. So not saying that you would do that, but I think that that's, it's an interesting thing, but it's a bunch of work to build it, right? Yeah. So if you have other things that are more important, you might not do it. But it definitely, the sandbox is such that you can do stuff like that. And we also have just our own, we use something called OmniSoc, which you're probably a little familiar with, maybe you've heard of it. No, it's out of University of Indiana, but they basically, we have Zeek running in a lot of our sites, and we just send that all to them, and they're basically looking through all that data to like see if we have problems. And apparently lots of the big compute centers do this. So they have they're just a bunch of tools they use to like look through all the Zeek information. And part of their mission is to have a lot of that data be open. So like you as a security researcher could just go say, hey, can I have Fabric Zeek logs or something like that? And if you're deemed, safe enough to give them to you, they will. Right? And then you can do research on that. So that's something. Yeah.
About page, I see this highlight on GPU nodes on federated testbeds. Could you speak a little bit to that? Is it like accessing multiple slices and multiple GPUs, leveraging these different resources?
What is this? Let me just look up here. I just want to see what you're
doing. It just happened.
Oh, okay, got you. Yeah. So basically, like, one of the things that like we were asked to do is like, how could we have like more GPUs available, basically? And one of the ways is through our facility ports. So what you can do, and that particular thing that Ben was doing, he uses GPUs that are in Chameleon, and basically you can create a slice on Chameleon and then one on Fabric that kind of behave as one experiment. So you can use their GPUs, they have more of them and they're bigger and they're all in one place. So you can kind of use a hybrid of like these ones that are like centralized and these ones that are distributed all together. And there's a few different techniques. So like, I did a lot of the work building the Chameleon Federation piece. So you can actually create like a layer 2 circuit to Chameleon that you own. But we also did a thing where you can, the Chameleon has a piece of FabNet in it. So you can just launch VMs, or it's not even, they're bare metal nodes in Chameleon that are already connected to your Fabric network. And then if you do that, like if you go to Chameleon and launch a bunch of machines that have a bunch of GPUs, make sure they're on FabNet, then you can just access them from Fabric. Or if you say you had a facility port in your research lab somewhere here, you could access them from your research lab, right? So that's kind of what Ben's been talking about. He does things with like, they do ultrasound imaging of some sort. So they're like, it's all like image processing stuff using GPUs.
Basically access, say like Chameleon's GPUs if we had to set it up, right?
Yeah, for sure. And you could even, and this is like, I don't think any campus has done this yet. Actually, I'm not sure. This seems like something someone should have done. So like I said on Fabric, or sorry, on Chameleon, we, like if you're a Chameleon user, is anyone a Chameleon user? Anyone use Chameleon? No. When you deploy a node on Chameleon, you have to choose the default network that you want to use. And you can either create one for yourself and do all sorts of crazy networking things with it, or you can just use one of the ones that's available. And by default, there's one available. It's just like the shared network everyone gets to use. But on Chameleon, we actually created a second default one that is FabNet. So if all you have to do to have your Chameleon node be on Fabric is just choose that network instead of that network, hit go, and it's there. There's a world in which someone's campus does the same thing, right? So you could have like a lab of computers that are just on FabNet, right? Just permanently. Or you could have if you have some sort of virtual machine cluster, you could have an option of having them be on Fabric. Yeah, anyway, it's a thought.
Basically, yeah, getting like a shared allocation or something that we would have on Chameleon maybe and spin up some resources that we could, they can be leveraged through our infrastructure through the facilities.
Yeah, and you can flip it around too. And you could, if you did something here that had a bunch of resources and you put it on Fabric's network, you could then use some small piece of Chameleon, but use a big piece of you, right? Yeah. So it's really about combining them, creating isolated sandboxes so you can do experimental things. And then what we'd really like you to do is use some of the computation and stuff in the middle of the network to do something interesting. Right? Yeah, there's a lot of papers, at least 69 of them so far, 68, whatever I said it was. Anything else? Let me see, what was I? Telescopes. So there's a lot of like Asia connections, Japan, Guam. Like, what are things that we could do with that? I know we work a lot with Kevin Thompson from NSF, and he's the reason why there's a site here, because it wasn't originally in the plan. He basically said, we should have one here. And then he talks all the time about Guam being a thing that we should make happen. But yeah, I don't know.
And then I don't know if I see him on the Zoom, but I'm not sure if he's on the Zoom. he's like Guy Cooney's counterpart over in Guam. So they're collaborating with us. So there's potential for maybe helping them more effectively access some of the Fabric or Access or any of those other pieces of infrastructure, just because they're even further away than we are.
Yeah, and it could be, in my mind, there's a couple options. Like the easier one would be to create a facility port there if they have something there that some facility or instrument or data repository or whatever, and then you could deploy things across anywhere in our footprint and push or pull data from Guam over the network, and then like the more extreme version is like put a whole new Fabric site there, right? And that costs more money, right?
sites.
Be especially cool. I don't know if they have connections. I don't exactly know how the connections go over there, but I think our site in University of Tokyo is connected to both Seattle and Hawaii directly, I think. Or no?
Correct. So it goes through
Maybe our connection also does that. It's just transparent to us. Like, but anyway, like having, like Guam could have connections both directions, like connections to here, but also connections to Japan, and maybe who knows what else is there. But that would create another site that's already over there. Yeah. Yeah, we could reallocate Seattle to the US. Actually, Hawaii is probably technically part of the US, well, Guam as well, right? So anyway, close enough. Pacific, we call it Pacific. Yeah, that's what we should have called it, I guess, maybe. I don't know.
They have some researchers that work with like drawing light image stuff that have collaborations with like folks at Stanford. They do photogrammetry type stuff. So it's like petabytes of data. Like institution together to build their kind of mapping of watersheds and things like that. So
Where do they store that? In Guam or like just wherever they can?
I think they've been. I think it's at Stanford, and it might have been on GCP. I don't know where it all is now.
Cool. Well, everyone's tired. It's been a long day trying to learn lots of things. I know I'm tired.
Things. I don't know if Sage, but like if there would be anything interesting if like Sage were connected and slowly port from here to EVL in Chicago, if it would see enhancements in, since we're already on internet too many.
We don't really have people that do this stuff, but but Jupyter is so good at for that. So it's like the people that know how to really manipulate pandas tables and stuff, they can generate really awesome things. We had some students a while ago, and I helped them a bit. But we had something called Cytoscape, which was a tool that you could use to kind of make graphical representations of these topologies. It was really cool. It just never got quite perfect enough, and then that student moved on. So there's some code that's rotting somewhere.
Fairview is like what Jason uses for some 3D model and stuff, or like LiDAR things. But you can have basically like a client to see the render and run there.
I don't have much else prepared. If you want to talk more, we can talk more. Sure, we will talk. All the people online, try to get to meet more of them.
The only thing that I'm thinking of is just how to make my AI stuff go faster. Which I don't know if it would be leveraging like stuff that we're in.
Yeah, you might be interested in some of the stuff that I'm not well versed enough in it to really do justice with a demo, but some of the stuff that the developers that are playing with is pretty impressive. I'll need to learn more about it.
So, like on the education side, how many other institutions are like doing courses through Fabric for like allocations for?
There's like at least a dozen. I mean, the number goes up all the time. Except it's hard to tell because like most of the instructors that are doing it are using it like every semester, so it's the same people. But I used to have a slide that listed the number. It was like, yeah, at least.
Interestingly, maybe along those lines, since you could, like, has anyone looked at like they have like the indie competition for like building like compute clusters, like I think it's just some other class, but has anyone ever done it in Fabric?
No. It would be interesting. Like we don't, I mean, we don't have like super compute power, but we have really interesting.
I think the idea is more like is being able to go through and build something that works.
It would, yeah. I'm always interested in having people do something. So, yeah, I don't know how to. We should like create a competition. I guess is what you're thinking. Like maybe at one of our events, we can invite a bunch of students, have 2 or 3 teams, and have them spend the day and a half building something.
Yeah, or you might have a discussion of it. Maybe it's indie systems cluster competition. So it was like we didn't get into the supercomputing cluster, but you could do indie, which was all on virtual stuff. So Fabric could be another place.
NDCC, is that what you
I
said?
think it is. Yeah.
I'll at least take a note about it.
So, NESCC.
What do you think it was? What?
So like indie, like INDY-SCC.
SCC like this. Like Google this, it should be all right.
INDY-SCC.
Yeah, this one. Yeah, I guess 25 would be better.
Yeah, they started a few years ago to help student competitions like be able to eventually maybe get into the in-person SC competition. But
So there's a virtual version of that. Yeah.
something like this for using Fabric for that, and then but also maybe partnering with like the Linux Cluster Institute. Right, some advanced networking or cluster related things that they can build within Fabric. Because we had them here and they did, I think it was Luster, like parallel file system, it was like an advanced topic.
Yeah, cluster competition put on Fabric. The hardware is that there's no equivalent. Who's going to use something else that works the same? Maybe there's something.
Well, this is open stack. I mean, I can go in
True.
connecting up just a couple of nodes. But I don't know if there would be any, they could use the P4 or some of the other interesting things to see if there's a performance enhancements. Interesting to do.
Maybe
But
there's
it's just another way to get on
Yeah.
Fabric and
maybe we have our own. The P4 angle is pretty interesting.
where you move the field.
Yeah. We have the Bluefield stuff that actually originated. We have a grant that is led by University of South Carolina, but we're on it. There, it's a cyber training award. So it's a cyber training award for them to create materials for teaching how to use Bluefields. And as part of the grant, we bought like 20 of them. We're putting them all over Fabric. Most of them are out there right now. So much tailwinds that. But yeah, they have money to do cyber training. I wonder if a competition. Talk to Elliot beforehand about that.
It's like a hackathon competition thing. You can like build something hands-on using AI. What's like the big things that people want to use the fields?
What do they want to use? I think that, like we kind of said earlier, like blue fields are about offloading computation to the NICs. And inside the NICs, they actually have, like, one of the things is this. So I think this is probably the biggest one that Fabric people want to do. Use it for is just to do keyboard things because we have Tofino switches, of course, Intel and Barefoot stopped making these. So the Tofino switches themselves are dead, basically. You're never going to go buy a new one. The Xilinx FPGAs were kind of the new place where people were doing before. There's lots of like licensing like hurdles to get through to like make that work. And it's like kind of complicated to make it work. And pretty easily, if you give them to like novice people, they can like print these cards. And so a whole bunch of stuff that's just like kind of sketchy about them. They're really, really powerful and good, but they're hard to like share in like an open way. There's also some software-based things. So that there's like DPDK, for example, which is like the way to access the network cards, but like skip the operating system that's on the host. So you can have an application that's doing things on the card. They can get really good performance out of that. However, it's all super complicated. This Bluefield stuff makes it kind of easy. It's like just built in. The card itself has like a couple of NICs that go to the wire, a bunch of like interfaces that go to the machine. So you can kind of have like SROV virtual functions that go to the host. So now you basically have a switch. You can just kind of run before. That's how it works. So I think a lot of people are thinking that's the best way to do it. That's one of my. I think there's bigger stuff. I was saying earlier about the Kubernetes ceiling project, where they basically take all the Kubernetes networking stuff that's really complicated, push it into the card and get it really high performance. So that's what like the industry. It's how do you? I don't know if you were there when I said it, but the number that I heard people say repeatedly, so somebody said it, everyone else is that we are a hyperscaler, so Amazon or whatever. 30% of the compute power that you're using is going to managing the network for VMs. And if you can offload that compute to the cloud, you can sell 30% more CPU time. So that's the huge goal. Right? I think our people just want to do it.
Yeah. I didn't see anything else from the folks online. So.
But we might be done.
Yeah, I think you can.
Yeah, that's good. So yeah, thanks for having me here. I really hope that everyone got enough of a taste that, like seriously, by the time we have the NIT event here, should be at least 3 or 4 or 5 projects that you guys have come up with and done something. And if you need more help, you can find us. We have all sorts of ways to, like, if you want to have a project that you want to have like a one-on-one meeting with a group of us that can help you get there, do that. If you want to ask something before, we can do that. We want to make it work. Probably a bunch of you need to create projects so that the other people can be members of those projects.
I have one project created for our Skype, so I can post to that. So
let us know if you write a paper. That's really important. If we don't get funded, it's because we can't. We have to brag about you to get more funding. We don't have things to brag about that won't pay for anything. Other than that, yeah, it was good. I think we got a bunch of new users. Hopefully, have high expectations.
Thanks.
Thanks.
Good.